Very good morning, everyone. Is everybody in? Where's Chaitanya? Okay,
Good morning, sir.
I cannot see Chaitanya. Nukul, very good morning. Very warm welcome, everyone. I hope you all are settled down. I'm always surprised to see when everyone is so quiet. Would you all be always this quiet, even if you were in a classroom? I wonder. I doubt, of course. Very good morning, Jyotsna. So we have Sridhar, Muskan, Karishma, Likhit. We have Jyotsna, Vishnupriya, Yukti, Nukul, Gulshan, Prerit, and Rohita. Can everybody hear me? One by one, everyone, just tell me about your well-being, of course, with your name, so that I know you are present and you are ready. Chaitanya, you're the first person I was looking for, and you're the first person missing. I know you had disconnection. So, are you there, Chaitanya?
Good morning, sir. I'm there.
Very good morning. Very good morning. Yes. So, one by one, quick, short, brief. How have you been? What's happening with navigation, with your life? It's been a while, right? I've been waiting to meet you all. It's been so long.
This is Vishnupriya. Navigations now, after completing 1/6 rule, I'm feeling that I can do it, and things are getting smooth. And we are also, I have gone through the revisions. That's it.
Nice to hear that, Vishnupriya. Very nice, very brief, very specific. Very good.
Good morning, sir. Gulshan here.
Very good morning, Gulshan.
The navigation I'm trying to learn in class only, and right now I'm mostly preparing for RT.
You have been assigned some tasks, revision and everything. I hope you remember.
Sir, regarding navigation or RT?
Navigation. I remember our last conversation. It's okay. No problem. As long as you're studying, I can understand the concern. It's okay. Otherwise, how's your vision and everything? Are you facing difficulties? Is it better?
Negative, sir. No difficulty. Now I'm good, sir. Going smooth.
Now, are you able to like learn online?
Yeah, yes, sir.
Very good. Very good. Very nice. Nice.
Good morning, sir. Muskan here.
Very good morning, Muskan.
Yeah, sir, I did last lecture's revision and I was busy with RT lectures for few days.
How are you feeling about navigation so far?
Good, sir.
Very good. Very good. Nice to hear that.
Good morning, sir. Victor Tango Juliet Yankee Oscar.
Very good morning, Jyotsna. Very good morning.
So going good with navigation revision and also side by side revising MET.
Very good. We're gonna meet soon for Met Live. Very nice. Very nice.
Good morning, sir. Victor Tango Yankee Kilo India.
Very good morning.
Revising navigation lectures right now, and revised VR lecture, last VR lecture too.
Very nice. How are you feeling about now?
Sir, good. Confident.
Very good. Very good.
Good morning, sir. Rohita here.
Very good morning, Rohita.
I have done, previous lectures almost, and like you have assigned tasks. I've just read it and I have to revise it.
I'm very impressed with the way some students are giving me regular updates. Rohita, Muskan, even Vishnupriya, everyone, of course, but some students are doing it more religiously. And it is very impressive. Very good. Nice to hear that, Rohita.
Good morning, sir. Victor Tango, Yankee Zulu.
Very
Sir,
good morning, Likith.
Sir, all good, sir. I've revised PR and sir, I'm struggling with QDM and QDR questions with drift.
What's the struggle?
I'm just confused, sir. I can't get it.
Talk about your confusion in brief right now.
Sir, I have to go through questions again.
No, let's talk basic. What is the basic confusion like? There could be one core element that confuses you. Is it the definition of QDM, QDR, or is it the understanding of drift and allowing the drift so that we can either add to our heading or subtract from our heading to get the required heading, right? The calculations would always be with respect to, this is for everyone, okay? The calculations will always be with respect to what should be your present heading with respect to your required track when you have drift. Now let's take a couple of minutes in between what we are doing with respect to you talking to me, and everybody focus on this point that I'm saying. If you think it's important, it is important. If you feel it's important, make a note of it. What is drift? You'll see a lot of questions in the exams with respect to drift. Okay. It is not good for us to not stay on the required track, right? It can be said for everything in life. But when it comes to aviation, when it comes to CPL ground studies, and when it comes to navigation, it is the most important thing to do for you as a pilot. But let's assume none of you all have ever been into an aircraft to know what we are talking about. So how would you as a student imagine on a piece of paper? It gets very difficult. So we start with the first few references. Okay. Remember, we're talking about drift right now. I can say drift is a topic which is universally applicable in your navigation exams. Drift could be given to you with respect to questions coming from directions, CDM weighting, track error angle, VOR, required track, present track, NDB ADF, that is relative bearing. What else? That sums it up. So when we talk about references and the points that I've just said, we understand it's all related to directions. So the core to understand drift and master drift, one of the most confusing factors for most of the students who start learning, and in a span of 2, 3, 5, 6 months, it's not enough to get a hands-on experience. So I understand every time a student gets one concept, there will be a following doubt in the next question. Why does that happen? So we're talking about staying on track, and the references are the track that we have. What are these tracks? We can simplify these tracks with respect to directions, and we know we have 360 degrees. Now that is what everything is all about. But how do I understand drift here? I know directions, I know 360 degrees, I know cardinal points, quadrantal points, everything. The next reference is how are directions measured, okay? Directions are measured clockwise from reference north. If you don't remember this simple point, you will never get correct answers everywhere when you get such questions. Partially you might get it, partially you might not. I've seen that a lot. We need perfection, right? Every mark counts. When you aim for a score of 85 or 90, you give yourself a blanket, a cushion, I could say, of 10 to 15 marks. So when you aim for 85, you get about 70, 75. So I say, why not aim for 90, 95? Many of you all think that, sir, syllabus ho jayega to 100 aa jayega. It's not about that. Of course, syllabus kar lo, zaruri hai. But you do the syllabus, it's important. But if you don't understand these basic points for every concept that you learn, your understanding for every element becomes 50%. So even though you have completed 100% syllabus, your understanding would be 50, 60%. So how can you expect yourself to score 85? To get 75? This is something which is very serious in aviation. I don't know where you come from or what you have done in the past. But that's the strategy here. What's the strategy again? Whatever I've studied, have I studied it 100%? So the 100% starts from 360 degrees with respect to drift and clockwise measurement from reference knot. Clockwise. This is very important, clockwise. Why is it important? Now let's assume, everyone imagine, okay? Let's assume, if you can sketch everything that I'm talking about right now. Let's assume your required track is 000 or 360, straight up, north, right? Where would be 005? 5 degrees to the right. Drift is nothing but a relationship between this and this. That's it. But do you understand what this is and this is? If not, then you still have a lot of studying to do. Let's assume you know what this is. So what is this now? I would say one of this is a required track. One of this is a required heading. Why are these two different? These two are different because I am experiencing drift. Sir, what does it mean? Okay. It means, let's say my required track is north up straight and my heading is also straight, 360. And I get a wind component. A wind component exists everywhere in the world and it will always be affecting your aircraft somewhere or the other, unless you have still air conditions. What are still air conditions? No wind. So the reference here, then again, so there are many, many, many references that you need to master and you cannot afford to forget it. Now, again, the reference here is in still air, your aircraft can continue to fly straight north like this because there's no wind impacting my aircraft. My aircraft is designed in a way that it's very sensitive to air. It's so sensitive that a particular angle of attack lifts it up. A megaton aircraft lifting in air. I cannot even make this little paper stay in air. Can I? No, it will fall down. Aircraft is more sensitive than this. And it is controlled sensitivity, I would say. Something like this, something like this. Now, what is this? This is an airfoil. That's it. Where do I get this on the aircraft? I get this on the aircraft on the wings, the parts that I've covered, the cross section. You are running somewhere and someone is pushing you from the left. You will go. Okay, my left is this. You will go on the left. You are running, someone is pushing you on the right. You will go right. Now, from where do you think the person pushing you on a right will come from? This is my right. Let's say somebody is going to push me to my right. So where will they push me from? They'll push me from here. What is this side? This is left. From the left, somebody pushing me, when I'm running, I go on the right. Similarly for an aircraft, wind. What is wind? Air in motion. What is air? Mixture of gases. Gases are nothing but matter, just like solid or liquid. This wind that I'm talking about right now, it's just like the person coming from left, pushing you on the right. And the wind coming from right, it's just like the person from the right pushing you on the left. Now, what is left right in aviation? Port, starboard. Port, starboard. This is another reference you cannot afford to miss. But all these things we take for granted. Why? I don't understand. But we will not make those mistakes. Do not lose the track of what I'm saying, okay? Now what happens, as a general understanding, somebody pushing me from here, I will go here. Now this is the real concept of drift. Then what can I say drift is? Drift is drifting away from the required track. Drifting away, not towards. So the term drift comes from maybe moving other side of your required track. Drifting is just wandering. Drifting is wandering directionless. Drifting is wandering without your intent to go somewhere. Someday when someone is just walking to clear their mind, not knowing where they are going, they are drifting. Can we allow our aircraft to drift? We cannot allow our aircraft to drift. We need our aircraft to go where we require it to go. And who's going to control it? You're going to control it as a pilot. Nobody else has the controls. If you remember anything from regulations, PIC is the sole authority, right? So now I don't want my aircraft to drift. What is making my aircraft to drift? Any wind component. How do I narrow it down with respect to any wind component and limited wind component? Any wind component I can first classify with respect to 360 degrees directions, because that's how wind is understood to affect us from. Something very interesting about wind, the way we measure wind, is wind speed, wind directions. We all have done velocity triangle. We have mastered it. Everybody has done brilliantly in lecture 1 and 2. If you remember, if you have revised. Speed, okay, there is a windsock and there will be so many other things. Windsock actually shows you the direction of the wind. What are directions again? 360 degrees. With respect to us, so far directions are where you are going. With respect to wind, there is a difference. The difference is where is the wind coming from. So if I am going north and if the wind is coming from north, so this wind, for wind, the heading would be 180. If there was a concept for a wind to have heading, which is not. But how do I understand the direction of wind? Where is it coming from? If it comes from north, and if I am going north, then it will be a headwind for me. Now that is headwind. If I am going there, and if the wind is coming from south, 180, if I'm going north, then it becomes tailwind, because the wind is getting into the tail of the aircraft. Headwind, tailwind. Headwind, tailwind. Simple. Now, on the right side of this line, 000 to 180, on the right side, okay, I can say the entire semicircle on the starboard side. What are the directions available? Starting from 000 in the center, the first direction on the right could be 001, and it will go up to how much? 179er. So all the winds coming from 001 to 179er, all those winds are coming from which side? Right side, starboard side. So where are they going to push you? Of course, on the left. Remember this, students. Nobody ever will be able to give this to you right as if somebody is spoon feeding you right now. Make the most of it. What did I just say? From 001 to 179er, including all directions, if the wind comes from that direction, it means it is coming from the right, but only if my aircraft is following a heading north. All of a sudden, if I change my aircraft's heading to 090 or the required track 090, the entire concept changes. Now, for me, the reference for starboard and port wind becomes the directions east and west. Anything from 090 to 270, this part of the, what is this now? 360-degree directions. This part becomes starboard for me. So it will be 090 1 to 269er, because 090 will be head, 270 will be tail. And anything 089er and from 271 onwards till 089er, the other side of the semicircle, we can call it as 271 to 089er. That will become port wind for me, because the wind for me is coming from the left side, from the port side. So wind is coming from the port. Wind is coming from the starboard. Now let's change the heading again. 180. Right like this, 180. Again, for me now, starboard and port winds would change with respect to me. So whatever my heading is, you cut the 360-degree angle directions into halves. Whatever is on your right, if your wind is coming from one of those directions, it means that wind is coming from starboard side. That is right. And anything that is on your left, the wind is coming from port. I'm giving you a few seconds to soak it in. We are not there yet. We are getting there. Getting there to how to figure out. So far, anyone who's not understood what I'm saying?
Negative, sir. Understood everything.
Think. Think, students. Giving you time to think. Have you understood how to determine whether your wind is from starboard or from port? You're talking about the wind at the moment, not yet drift. Remember, but we already know something about drift, that anything from the right is going to push me on the left. Anything on the left is going to push me on the right. Simple. The same is true. You know how is wind calculated? You know how to determine your own personal starboard and port with respect to numerical directions. Chaitanya, how much have you understood so far?
Sir, I've understood this topic.
I'm talking about right now. How much have you understood?
Yes, sir, I've understood 100%.
What do you mean by this topic?
No, sir, I mean the just now you said. I was meaning by that.
Okay, very nice. The greatest confusion that you will face in your numericals is yet to come. Okay. Everyone, revisit all the starting points that I've said in your mind. If you want, you can make a checklist of it. Quick. Make sure it's thorough. Don't wait for tomorrow. Don't wait for later. Do it right now. Because this is at the core of everything. When I say at the core of everything, it can be asked anywhere. It can be asked in VORs. It can be asked simply in CDMVT questions also. And you might miss out if you don't know this on basic CDMVT questions also. Luckily, your CX3 gives you a lot of possibilities to figure out drift, wind correction angles in most of the cases. But many a times it doesn't. That's where you need your mind, the biggest computer in the world or the biggest calculator in the world, to do the hard work. Do not take this for granted. This is where exactly you get combinations with respect to questions like this QDR, QDM that Likith is talking about. That generally comes with respect to relative bearing and magnetic heading. And those questions are generally related to NDB, ADF based relative bearings. So you now need to know which type of questions are related to which type of topic, and practically what is the application, which instrument am I following to give me directions, and what I need to be careful about so that I don't deviate from my track. Now, talking about deviation from a track, there's not much difference with respect to drifting and deviation in layman's language. But when it comes to your navigation studies, there is a huge difference. This is another point why you will see, if you don't do consistent revision, you will be confused about these topics. Think, students. Now, to master this, to master the resolution that a pilot needs to make when something happens to the aircraft, when there is a wind at the designated flight level, designated flight path. Now, when I say flight path, what is flight path? I want everybody to write this. Flight path is the direction traced by the CG, that is center of gravity of the aircraft, when the aircraft is in air. What is flight path? You can say it's the direction traced by the center of gravity of an aircraft. This center of gravity of an aircraft is again one of the cores to understand drift. Now, who would have thought, sir, mass and balance and drift? Never heard about it. I'll show you the link right now. By link, I don't mean digital links, connection. Otherwise, सब लोग WhatsApp check करेंगे, so link भेज रहे दूसरे वीडियो का. Now, that's a joke, huh? In these days of sickness, I have gained a lot of sense of humor. And if you all remember, my success rate with my jokes was 50%. Now I think it's increased to 60%. So you can all feel free to laugh, okay? But not at the cost of losing track of what we are learning. As a pilot, I'm sure you can multitask and keep your focus. You're required to do that. You'll always see one of your crew members will be talking about something light, even though you're working. That's to beat the stress. That's why ATCs in real life are so informal. Anyway, why CG? Now, this is very important to understand. Let's say I'm holding the aircraft in a place CG. Where I'm holding it with my 3 fingers right now is the CG of the aircraft. Now, the problem with my aircraft is when I talk about drift and the difference between drift and deviation, okay, is this and this only. Whether my CG is maintaining the track or the direction. Now, when I say the flight path is the direction traced by the CG, that could be a required track. That could be track made good. So now you know there are 2 tracks. A required track is the direction that you need to follow. Track made good is not a good track to be on. I wonder why they call it track made good, right? I think it's sarcasm, whoever invented the word. I think it's wise humor. So when we are talking about track made good, we are not talking about drift. We are talking about deviation. Now, this deviation is not the CDMVT deviation, okay? This deviation is deviation of track. Now, what is this track? It is the required track, the required direction to follow, which you get from your charts, which you get from your airways. It could be a radial. It could be a QDM or a QDR. Now, QDR is a radial. Even if I don't have a VOR, I can still maintain QDR with the station. We need to understand these little things. And when you understand these things, you'll see you'll score amazing marks. Amazing as in beyond 90. I've seen that happen. So what are we talking about? We're talking about required track and we're talking about CG. Why are we talking about CG? Because the wind component, let's say I'm getting, let's go back to our required track of 000 in still air conditions. Suddenly I get a starboard wind. What is this going to do? Now, as a person who's not very specific with aviation terms, what do I get to see? I see that, okay, I'll show you from a top view. Imagine you're hovering above the aircraft. So let's say this is from the right. So my aircraft, I assume, will be pushed like this. But that is not what happens, students. What happens is the aircraft first moves about its CG when a push is applied. Only after that, if no corrections are made, slowly, instead of staying like this on track, slowly, it will go like this. Now, when I say no corrections made, it means you had to be on 000, you're maintaining 000 heading. So if I'm getting this, my aircraft is going to be pushed like this. Like this. But this is not drift. We call it track made good. This line. Now, what was this line? How did I get this line? Because although my aircraft is going like this, my CG is tracing a point. Again and again, all of those points connect to this line like this. So required track 000, and I'm gone here. So I am deviated off track and I'm left off track right now. Do I need that? I don't need that. Why do I not need it? Why do I not want to be on track? It's an aircraft. There are no hurdles in air. You can always come back, right? It's because you have limited fuel. And it's because you might not have air traffic control services when you are deviated. It's not safe, basically. So now to understand drift, we come back to the CG. And before we come back to the CG, we again come back to another core. And that another core is flight planning. What is flight planning now? Make sure when you're going to your flight training school, you learn how to do flight planning. They don't really teach it much unless you pester them to teach you, okay? Now let's come back to where it all starts from to understand drift. Now these are the final pieces of the puzzle that I'm going to say. If I have to fly to Nukul's hometown to celebrate his success party, let's say I'm going to plan. I'm going to fly my own aircraft, and he has some good small airfield. Many small rural villages have a small strip. So I land there. So I'm going to plan. So for that, I'll need charts. I'll need a protractor, something that DGCA doesn't require you to learn. I wonder why for CPL exams. Let's say I figure out using that technique that I have a required track of 0, 0, 0 to go to where I want to go. Is that enough? I'll do fuel calculations. I'll do everything else. I'll submit my flight plans. I'll get my clearances. Is that all? No. One important element that I have to look out for will be the impact of, or the existence of, or the knowledge of the weather, and not just the weather, the winds. So let's say I've been cleared only for VFR. I'm just thinking in my mind I'm flying Cessna. So let's say VFR. So let's say flight level 80 is cleared for me, or 900 is cleared for me. And I get the information from related service providers to tell me about the existing wind on my route for that particular period of time when I'm proposing to fly. Let's say I want to leave in the morning, let's say 8 a.m. or something. So I know 8 to 9 will be my validity approximately for my clearances to fly, for my flight plan to be valid. So in that time, 8 to 9, and let's say my estimated time of travel, total estimated elapsed time from me to my destination is just 45 minutes, let's say. So I need to know between that time, 8 to 9 a.m. on that particular day, what would be the wind at my assigned flight level 900. I need that information before I go. That is where drift comes in your navigation studies. Okay. So let's say Likhit is in connect with one of the meteorological offices or any agency that is going to give me that information. And he's got it to me. And the information that I get is that in particular, in that much of time that I propose to fly, there's not going to be any wind. Still air. I'll be like, if I'm a lazy pilot, I'll be like, very good. I'm happy. And I think somewhere when you will be learning, you all will feel very lazy. And the laziness comes with the help of difficulty. In the name of difficulty, it becomes very difficult to stay on track unless you really learn what your instructor is trying to teach you. But it's very easy in still air. But you'll not always get still air, especially at lower flight levels. You'll always get some or the other wind, always, most of the times. So if I get still air as my forecast, it's a forecast now. Nobody can definitely say, right, if it's gonna happen. It's just a forecast. And I believe that forecast. So I know my required track and my required heading, both are 0, 0, 0. Now this is where the drift comes. Required track, required heading. Okay. Still air, 0, 0, 0. So I'm flying, very happy. In that case, my track and my heading will remain the same. When your track and your heading are the same, the drift experienced is 0. Shunya. All of a sudden, when I'm prepping my aircraft during the doing the fueling and all, real time, let's assume 7 a.m. in the morning or something, very happy, got aviators on, everything. Maybe got some gifts for Nikul. Okay. So calculated everything, all the payload, everything. Suddenly, Likhit's contact tells me, okay, there's an update. You're going to experience some amount of wind, maybe 15 knots from 09 at 0. 15 knots, 09 at 0, checked. I'll forget everything else. I'll not forget everything else, but I'll remember this also. Okay. Okay. So my required track is 000, but I have a wind from here and here. So I have to do some corrections. So this is where in your exams, drift comes from. In your textbooks, in all the literature that you have, this is what drift is. We call it anticipated drift. We call it anticipated wind. It is a correction that you will pre-apply when you're flying. It's a correction you will pre-apply. So after takeoff, after my ATC clearance, once I've reached a point from where I'm going to resume my normal navigation, of course, not on autopilot on Cessna. I am the autopilot for Cessna, I would say then. Then I need to know what to do to stay on track. And what is my drift? When I know my drift, I can apply corrections. And as a pilot, the only correction I can apply is to my heading. That's the only thing you have in control other than angle of attack and thrust. Angle of attack is a limited range. You don't want to play with it much once you've reached your cruising altitude. Thrust, of course, you're always on full. So the only thing that you can manipulate again, or from now onwards, once I've reached that point from RNN, resuming normal navigation, I need to know what should I do to stay on 000 required track. So this is where the CG comes in place now. Wind coming from here, it's going to push my aircraft here like this. It's going to make me go on a deviated track, which I don't want. I've not spent much on fuel. I don't want to waste fuel, I would say. So what do I do as a pilot? Now look at this, what drift is, students. This is guarantee going to give you 15 extra marks in the examination. 15, I could say. Okay. When coming from here, I am going there. How do I apply the correction? I move in the direction of wind. What did I just say, students? How do I apply the correction? So simply said, but it's the most important thing. To allow the aircraft to stay on the required track, when there is a wind component, which is not a headwind or tailwind. Headwind or tailwind is not going to give you drifts. It's just going to affect your TAS. So anything on those 178 directions on your right and 178 directions on your left will impact. So what is this correction? The correction is in the direction of the wind. And this is the forecast wind that you get before you take off. So how do I do the correction? Controls. I have 3 planes. I can move in 3 dimensions. I'm going to talk about horizontal moment because it's directions. So the corrections are always applied in the direction of the wind. I hope you all are making a note of it. Somewhere I have a feeling couple of students are thinking this is not going to be helpful to them. If you are one of those students, please don't be like that. So what is this correction? This correction is to my heading. Still air, 000 required track, 000 heading. When coming from starboard, I have to apply correction in the direction of the wind. So this is what I do. This movement happens about my CG only. Whatever you do will happen about your CG in the aircraft. So this is where the CG comes in place. How is this correction going to help me now? So let's go back on the top of the aircraft to view as if we were gods looking from the heavens or hell, whatever is up there. and I see my aircraft going there like this, wind coming from my right, in order to stay on this track and not deviate. This would happen if I'm not doing any correction, but this is not drift. This is drift in simple language, but not in your textbooks. This correction in direction of the wind and the difference between your required track and your heading, this angle. Now this is drift. But which drift is this? Now, as a student, the first thing I see, sir, I am on the right of required track. It means I have drifted on the right. It means I have drifted on the starboard. It means it's a starboard drift. Now, this is something where everybody gets stuck. After learning everything, what they see, required track, heading, they see where is the heading. If it's on right, they say it's starboard drift, but it's absolutely wrong. This is the correction applied. This is the WCA in your CX3. There are shortcuts that people teach students. The shortcut is your drift will be opposite of your WCA. And it is a valid shortcut. But do you think aviation requires shortcuts? Never. So this angle that I see, the angular difference, I will get with respect to my velocity triangle or my CX3. The angular difference, of course, you will get from calculators. You don't have to figure it out. But then when your heading is on the right, it's not starboard drift. Then what drift it is? It is the drift that would have happened if I would have not corrected my heading. And this drift for the wind or by the wind coming from starboard is pushing me on my port, on my left. So this wind will always, a starboard wind, please make a note of this statement. A starboard drift, a starboard wind will always cause a port drift. But experiencing port drift, correction is applied always in the direction of the wind. So the heading will be always on the right of the required track for a port drift. If you remember, I think last to last class, I spoke about contradictions in aviation. What are these contradictions? This is one of the major contradictions. Where I feel my heading is on the right, so my drift is right, but that is not the truth. Why? Because I have allowed for the wind to give me a drift by making a correction to my heading to stay on the required track, the course 000 in my case. Visually, how does it happen? No wind, I am flying straight like this. No wind correction, starboard wind, I am going like this. Starboard wind with correction, my aircraft becomes like this. Like this. And my aircraft flies like this on track. Now, this is how I maintain my track. If you don't believe aircrafts can do this, look for crosswind landings. We call it crabbing. There are many terms to it. Up there in air, they don't say it is crabbing. During approaches, they call it crabbing. Why crabbing? Because crabs, they look straight, they walk sideways. You have to imagine this, that in order to stay on track for a starboard drift, I need to apply correction in the direction of the wind. And this is how my aircraft is going to fly and stay on track as long as the wind is going to impact. This was all anticipated because my contact gave me the forecast. And this is what I'm doing right now. Now that I am in air halfway through, okay? Now that I'm in air halfway through, I realize although I have applied the corrections, okay, because it's VFR, I know halfway through I have to look out for a big lake on my right. Visual navigation. I checked, I'm halfway through. I cannot see the lake on my right. Or I see the lake, but very, very far off. Very far off. It means even though I had made corrections and I was crabbing like this with anticipated drift, now that is drift for us students. Always in your books everywhere. Chances are I'll get more or stronger starboard wind again. So let's say halfway, I have realized my lake, which would have to be immediately on my right, is far off. And I anticipate and I realize that approximately I'm probably 4 nautical miles left of track, 5 nautical miles left of track. It means you are on a TMG. That's where your track error angles come into place. So you already had drift, you are crabbing. And now again, instead of being on the straight line, even after crabbing like this, you are doing like this. Now this is track made good. Required track. Heading, 3 different directions you have right now. Wind correction angle, another element. Drift, another element. Track error angle, another element. And then I need to have my track error angle corrections, TCA, 1/60. So even when the aircraft is drifted, you might be on a TMG. That will be because the winds have changed with respect to anticipated wind. You need to be aware about all these things to get 1 mark. And you have to do it again and again, again and again. 1 mark, 1 mark, 1 mark, 1 mark. And you have to do it 80 to 90 times. It's like creating a home with bricks, 1 brick at a time. So what is drift now? If I tell you what is port drift, do you think you'll be able to tell me? Or if I tell you the required track and heading, can you figure out what's the drift? Is it port or starboard? Anyone who cannot do it, tell me. Take your time. Victor Kilo India, go ahead.
Sir, I have some questions regarding drift, doubts and questions that I've shared you in WhatsApp. Can I share you again?
I'm sure if you try again after this, you will get the right answers.
Okay, sir.
Try it and get back to me. You can try now also when I'm giving some time. But you can obviously discuss verbally your doubts, students, right now. Couple of numericals, couple of examples. It'll give you more clarity. Students who are giving exams in the upcoming attempt, it's a sincere request to keep your videos on. Maybe not today, but from next class onwards. You have to follow all instructions. Okay, remember that. So sometimes, students, you will get numericals where you just have nothing but your anticipated drift. That's it. sometimes you'll get a situation where along with anticipated drift, there is a TMG involved also. And then sometimes you will have anticipated drift TMG along with a relative bearing or a VOR based QDR, QDM, whatever, to and from. Those are the only variations. And of course, you can always get still air, no drift with TMG and relative bearing, sorry, QDM, QDR. Those becomes your numericals because those are the effects you are experiencing as a pilot in air, and you are required to make certain adjustments to your heading, nothing else, just your heading. And of course, another element that you as a pilot would be required to do would be to control your airspeed in such a way that you stay true to your estimated elapsed time. So now if I'm getting exactly a starboard drift, like, what do we call this? A beam, 90 degree. It might affect my wind speed. Correction, my airspeed of the aircraft. So again, I have another strategy to understand if my airspeed is going to be decreased or increased. In other words, if I have to increase my airspeed or decrease to stay true to my total estimated elapsed time, is you're flying the aircraft, make a section. This is the aircraft. Make a section like this. Like there's northern hemisphere above the equator, southern hemisphere above the equator. Similarly, in your direction of flight, make a section. Anything above in the upper hemisphere, if the wind comes, be it starboard, be it port, it is gonna impact you similar to headwinds, and headwinds will reduce the airspeed. So you'll have to increase the thrust settings to stay true to your required plan. And anything coming from the other semicircle would act as a tailwind, would give you a little bit of boost. So you need to slow down the aircraft a little bit. That's the difference between ground speed and TAS. So ground speed is what we generally take, we could say, during flight planning. And TAS is what you actually feel. When you combine all of these, you're a master of general navigation. So there comes time, there comes understanding of the graticule, the directions. Everything is included in this flight planning. Also, I want to talk about measurement of elements. CX3 can easily help you get 40 to 50 marks in any given exam. Make sure every day when you're eating or maybe you're doing something else when you're not studying, you keep exploring the CX3 again and again. All features, everything, things that are not even in your syllabus. Keep exploring, be a master of it. You should know all available options because sometimes there might be some questions which you might not have solved before ever. But if you think about it, you might get the possibility to solve them using CX3 directly. Remember this point, please. Forget how you learn in other places. This is how you learn in aviation. When you understand these factors, students, you come up with answers just by looking at the options. It becomes direct. Don't even have to do calculations much. Some questions are that obvious. I can give this understanding the term maturity, but this maturity can easily be attained with focused studies, time and again. So anyone who is confused about these points, try to go through the text. If you don't have it, you know we have access and then resolve. Whenever you're resolving or solving, check your answers with the master key. If your answers are wrong, try to figure out why by doing reverse calculations. Because you know the right answer, you know yours is wrong. Compare why. How do you compare why? By reading the question again and again, seeing what are you missing. But generally what we do as students, so mujhe nahi aa raha, batao. Sir, I don't know, you tell me. I can tell you. Of course, I would love to help you. Will you be able to take me in the exam also then? Get the permission. I'll come and help you there also. The questions are such. The understanding has to be this, but the questions are such that you might have never seen before in your life. It doesn't mean you cannot solve it. But if you don't understand this, if you keep doing what you're doing as a small child, then you'll not get what you want. Something to think about, right? So what is this wind correction angle then in CX3? Everybody, open your CX3. Digital, non-digital. Where do you get WCA? This is what I need to apply to maintain my track to reach my destination. And after that, whatever happens would go into 1/60 as long as my error angles. The difference between TMG and required track is 20 degrees or less. Because 1/60 is only valid till 20-degree angles. And generally, as a pilot, you'll realize that you have deviated quite soon or sooner. 5-10 degree, 12-15 degree max. Sometimes it might happen that you have wandered off 30 degrees. But then, of course, we hope you will have a CDI at least to show you that you are off track. Now, everybody knows that CDI thing. It makes your job so much more easier. The straight line, indicator, needle shows you where your track is. Simple. How many nautical miles? Now you can figure it out with the dots, 2 degree, 4 degree, 6 degree, 8 degree, 10 degree. And applying the 1/60 rule if you know the range. And how do you know the range? You know the range through DME, and the DME is always co-located with VOR. In simple terms, wherever you will fly, we have that provision. So now you see the combination of general navigation directly jumping to radio navigation. You think it's syllabus? Students, entire navigation is one topic. You learn everything to do one thing, and that one thing is to stay on track. Have you ever thought about it like this? Entire navigation is just one topic. And I don't know whether you know it or not, but there's always a secret to everything. This is the secret for navigation. The sooner you get it, the better will be your life for the rest of your life. Not just exams. Exams are just a byproduct. Clearing exams will become a byproduct. You have to clear interviews. And then you have to consistently navigate. Otherwise, you'll be sacked off. What's the point? As a student at ICATS, this is what differentiates you. How you look at things. Even the best of students sometimes don't clear. So what? Do you think they'll grieve and they'll cry? If they do it, then they're still not truly attached to the passion of flying. But if they don't score, they should be like, Where did I miss 31 marks? It's not a good ratio. I cannot have a 31% margin of error. I cannot. As a pilot, no. As a pilot, I cannot have even 1% margin of error. So I will study for the sake of my dedication to my purpose to fly safe and protect my passengers, my airline, my co-pilot, myself, and my family. When you become a pilot, you just don't just realize your dream, you make a lot of other dreams come true. You become the center of your world and you help everyone else in your family and friends. That's what happens in the long run. You kind of become like a caretaker of everyone, but with utmost royalty. You give people life other than yourself. Good life, top level life. But nothing is applicable if you don't know what you are supposed to do. And navigation is one such subject that teaches you how to make sure you continue to stay on track and continue to stay as per the plan with respect to other factors, fuel, speed, flight levels, and everything. So wind correction angle is what you apply. So that's where you turn. But is that the drift? No. So in your CX3 right now, I've asked you to go through it. Put any hypothetical data. Go with required track or true course, that is 000. Put any hypothetical data. Play with it. Give some anticipated drift, wind. You get wind correction angle. Make that correction. Keep the same logic. Starboard wind. So this is where plus minus, the final piece of the puzzle when it comes to understanding drift, port, starboard, plus minus. What is plus minus? If you're moving clockwise, it's going to be plus. If you're moving anti-clockwise, it's going to be minus. That's simple. Now, why is it so simple? Because it goes back to the core. All directions are measured clockwise from reference north. So if my wind correction angle has no negative sign in my CX3, it means it's plus. It means I have to increase my heading or I have to apply correction in the right direction, I would say. Increase as in direction will increase to the higher value from the existing value. So if my wind correction angle is 5 degrees to the right, what is my drift? My drift would have been, if I would have not corrected, 5 degrees to the left, which would be port drift. But where is my heading right now after applying correction? My heading is on the right 5 degrees of my required track. So my required track 000, my heading 005 gives me a wind correction angle of 005 or 5 degrees. When I say 5, it is plus only. It means it's always right. Even if you don't say right, but just say 5, it means it's right. So don't let the right and left confuse you. And if the wind correction angle has a negative sign, then I have to decrease my heading. It means turn left by that particular degrees, that many particular degrees. So it all comes back to playing with the 360 degree when you are in the center. So you assume you're in the center. So your job becomes so much more easier now to find out what drift you are experiencing, even with CX3. But it's opposite of WCA now. Now I can allow you to choose that. Now I won't call it, it's a shortcut. Only if you understand everything that I've been saying. So if my wind correction angle is 5, my drift is 5 degrees to the port. I say again, if my wind correction angle is 5, as per CX3, then my drift is 5 degree port. Where is the wind coming from? Wind is coming from starboard. Where is the required track with respect to the heading that you now require to maintain? My required track is on the left. So people will play with your mind using a lot of words to confuse you. And that's what exams are all about. Now it's going to be very shocking, or you might take this for granted. But these exams are nothing but majorly a check whether you have common sense and logic. That's what CPL exams are all about, especially navigation. You develop this common sense and logic specific to your navigation. So you study navigation. You can apply the same perspective to all subjects, of course. Right now, we are focused on navigation. On the Zoom app, there are reactions. How you feel, choose one reaction and just post it. I want to see right now. With respect to what we are learning, not your personal lives. Confused, shocked, tired, afraid, happy, sad. The crying smiley will mean you are very happy only. I won't think it's funny because there's no funny business happening. Students use emojis, face, oh, yellow ball. No hands. I need the face. इतना तो कर दो यार. बाकी यहाँ का क्या हो रहा है? 4-5 लोग नहीं भेजा है. You're still thinking how you're feeling? Honestly. Because if I had to use a reaction, this is what I would use when it comes to my concern for you. Is there a smiley for how I feel? I don't know. Good. I'm giving you some time right now to discuss anything you have on mind on these things. And this is very essential to clearing your exams. Think. On a side note, I was studying something a few years ago, not related to aviation. Something new to me, something I always wanted to learn. And the teacher who was teaching that, he's no more, he's not alive. So he had trained teachers to teach. So he gave them everything word by word to follow, to teach. I think many big tutorials do that. Mahesh tutorials have, not Mahesh, sorry. Some of the tutorials I've heard that they have a specific way they tell the teachers to follow so that they can maintain the quality. There's no freedom of expression there. But that is not what I'm trying to talk about. I got a lot of knowledge from the books, from the learnings that I took. I was happy, but I wanted more. So I kept on looking for things that were not given to me from the institute. I dwelled deep on the web here and there, and I found out something that was almost lost, written by this person, this teacher. And I was happy to find it. There's a small booklet. In the booklet, the message is are so good that I think everybody can use them. All of y'all. Everyone. In that, the one thing that was emphasized more and more and more was to think, 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 think. I was taking it for granted until the repetition of think, think, think in the book made me realize that, okay, this is important. This is exactly what happens in your examination questions. You have to think. It is true. It is actually practical. When I realized the practical aspects of it already happening in our life, I realized, oh, what he had written there is actually true. So I tell you to always cross-check your answers before choosing the right option. Think. When you keep looking at the question to understand the elements and you think, and then when you look at the option, the answer comes to you. Now, what kind of student would you want to be? The one who wants to run behind answers, or the one who gets answers come to them? So don't take anything I say lightly. You might think, sir, topic पढ़ाएंगे मैं तभी ध्यान दूंगा या दूंगी, and topic नहीं पढ़ाएंगे तो मैं कुछ और कर लूंगा, कर लूंगी, दूसरा lecture देख लूंगा, देख लूंगी, business कर लूंगा. Then you are missing out on the most important aspect of the training here. Many students do that. That hurts me. But it's okay. Children make mistakes, right? So, clear or not? Students who didn't express themselves, any doubts? Can we assume that you will be a master of general navigation with respect to these topics or not? सवाल पूछा, कोई तो जवाब दो. या सब सो गए हैं? या सब इतने खुश हैं कि हवा में उड़ रहे हैं? क्या हो रहा है? Is there a monitor in class, a representative? Should we do that?
Okay, sir.
Spokesperson? Okay, right now, students appearing for March navigation, just drop me a message that appearing for March navigation quickly. Quick, quick, quick. Yukti, what's happening with respect to those questions that you had?
Sir, I've sent you the answer. I've solved one. So please check.
You tell me, are you able to figure out the confusions or not?
Sir,
And talk
yes,
to me about
I
the
guess.
situation.
Sir, just I don't know if you can check the answer. So please.
No, tell me the situation. Tell me the answer. I want you to
Sir,
talk to me about it. Yeah,
can
describe
you
it to me.
dictate you the question?
Not verbatim, in your own words.
Okay. Sir, in the question, there is two situation where the true heading is 90 degree, and when the true heading is 90 degree, the drift is 5 degrees south. And
It's not south, it's starboard. It's right. You have drifted, you're gonna drift to the right. So when you're drifted to the right, your your heading would be on the left. So it's not south, it's starboard. And if the drift is going to be to the starboard, then your heading would be on the left of your required track. Think
Okay,
about it,
sir.
fix it, and continue.
So means that when my true heading is 90 degrees, then the drift is starboard, 5 degrees starboard.
So these are 2 points given to you. Your
Yeah,
heading
and
is 0980, 3 digits. Students,
mm,
every time talking about directions, 3 digits. So your heading is 0980 and your drift is 5 degrees starboard. So what is your
yes,
required
sir.
track?
Sir, and one more situation is
Wait.
given.
What is
Yes,
your
sir.
required track then?
Sir, required track will
Everybody
be
answer to this question in the chat box. What is the required track? Yukti, you can give me verbal answer. First, find out the required track. Students, the exam message I want on our WhatsApp portal, not on Zoom chat. Your heading is 0980. Drift is 5 degrees starboard. What is your required track?
so 095, 905.
Yukti, sketch it and send me.
From sir.
Answers, everyone. इतना टाइम नहीं लगना चाहिए. क्या हो रहा है? What's happening? Answers, please. Half of the class is not yet giving me answers. Zoom chat. There's only one account right now. So here in this case, I'll just tell you how to figure it out. Your heading is 0980 and drift is starboard. So it means you have applied the heading correction. So you are experiencing starboard drift. It means the wind is coming from port. So the correction you have applied is to the port by 5 degrees. So the correction applied is giving you your heading 0980. So what would be a required track? It will be on your right by 5 degrees. So your required track would be what? I think 0905. Correct me if I'm wrong. Step by step. All it took me was few seconds to go step by step and come up with a solution without any numericals, imagination. But I'm asking you to cross verify because many students are giving me 085 required track. It is starboard drift. It is not starboard wind. Starboard drift means port wind. It means correction to be applied in port. So 0980 gives me a correction applied that because that is my heading. So if correction is applied on the port, my required track would be on my right. How many degrees? 5. 5 degrees right of my heading 0980 is 0905. I could be wrong though. Everyone who's given me 085, tell me if you're right or I'm right. Quick. I don't want to take names, but it's okay. इतना समझाने के बाद भी अगर आप ये गलती कर रहे हो तो आपको ये समझ नहीं आया है और आपके मार्क्स जाएंगे एग्जाम में. In English, even after saying so much, if you are not getting it right, it means you are not following what I've taught you. You're following the non-aviation logic of yours. Because it auto-suggests. The mind is such. You have to control that auto-suggestion. This is the common sense and logical reasoning I was talking about. And there is a way to develop it, step by step by step by step. Nukul, Likit, resubmit your answers. Muskan, Sridhar, तुम तो स्टिल एयर में ही चल रहे हो. ड्रिफ्ट है 5 डिग्री की स्टारबोर्ड में. क्या है ये? हाँ. And students, anytime talking about directions, I need 3-digit answers, no 2-digit answers. Remember that. चैतन्य, तुम क्या कर रहे हो?
Yes, sir, I have dropped the chat.
किधर है?
095.
किधर है?
Sir, I have dropped it.
कहाँ है?
I'll just drop it again, sir.
Please do. Because I'm unable to see it. कब से वेट कर रहा हूँ मैं?
Sir,
Yes, Muskan, go ahead.
are my charts visible?
Everyone's chart is visible. Yes. Now Chaitanya, I've seen it. कहाँ भेजे थे पहले? किसको भेजे थे? चैतन्य, अवेयरनेस चाहिए. अब कैसे आ गया? पहले नहीं आया. Chaitanya, more than anyone else, I want you to be instant.
Sir,
Right.
I've sent you the photo in WhatsApp.
I know. I will be checking it. Chaitanya, Rohita, Karishma, Likit, Sridhar. Okay. 0905. Makes sense to me so far. Vishnupriya, 2 answers. आप 2 आंसर नहीं मार्क कर सकते एग्जाम में. You cannot do that. I need 1 answer. Josna, 3 digits, remember? Muskan, fine. Nukul, Likit, any confusion?
Sir,
Nukul?
true heading. Sir, true heading is corrected heading, right?
Do not
After-
get confused with the terms true, because everything will be true only here. If that will be magnetic, then you will have to apply CDMVT also first. So true heading, true course, ignore the true heading and course. Heading is always corrected if there is a wind with respect to our questions. Yes, Nukul, go ahead. Carry on. Continue.
No, sir, that was confusion. I thought it will be corrected as a 90 degree.
Correction के बाद ही 90 आया.
After
समझे?
correction.
करेक्शन करके मेरा हेडिंग 09 और 0 है. समझ रहे हो क्वेश्चंस कैसे पूछे जाते हैं? क्वेश्चन आपको क्या ड्रिफ्ट हो रहा है वो नहीं बता रहे हैं. एंटिसिपेटेड ड्रिफ्ट बताते हैं. जहां भी ड्रिफ्ट होगी मतलब करेक्शन अप्लाइड है, वहां ही ड्रिफ्ट यूज होगा आपके एग्जाम्स में. समझ रहे हो आप? यही पॉइंट है. शायद ये पॉइंट आपको अच्छे से समझना होगा. This is what's going to make you all geniuses in navigation. Not many people know this clearly. तो मैंने करेक्ट कर लिया है ना. तो मैं लेफ्ट में हूँ. तो मैं कहाँ होना चाहिए था? मैं राइट में होना चाहिए था. बिकॉज स्टारबोर्ड ड्रिफ्ट है, मतलब विंड कहाँ से आ रही है? पोर्ट से आ रही है. तो मुझे पोर्ट में घूमना है. मैं पोर्ट में घूम चुका हूँ 09 और 0. तो मैंने लेफ्ट लिया है. तो कहाँ से लेफ्ट लिया है? 5 डिग्री. 09 और 5 से लिया है. ऐसा होता है यहाँ पे. तो मेरा रिक्वायर्ड ट्रैक इज 09 और 5. ट्रू कोर्स. आ रही बात समझ में? नहीं, रिपीट करना है बार बार. बस ये मिसिंग एलिमेंट है. लिखित, व्हाट्स ऑन योर माइंड? Nukul, figure it out. Tell me आया कि नहीं आया? Confidently. Likit, what's on your mind?
Sir, understood, sir.
Arey, you had a doubt na, Baba?
No, sir. Understood.
Yukti, continue.
Sir, then in the question, the true heading, when the true heading is 180 degree, there is no drift. So TAS is given 200 knots for both the situation. So we have to find out the wind direction and speed.
Very simple. Completely on CX3. So, point of discussion is carry on.
So I've tried in CX3, but it is I was getting little confused in 95 and 80, 095 and 085 for true course. So now I get that it's 095. The answer would be 170.
Everybody, write down. So now
One.
confusion resolved, is it?
Yes, sir. Affirm, sir.
Very good. Everybody write down. True heading 0980. Yukti, ये जो S लिखा है ना south, a suffix S stands for south only when we are naming routes on ATS charts.
Okay, sir.
With respect to other places like drift, it represents starboard, that is right. Please make the correction and send the picture again. I know why you are saying calling it south, but now please know the difference.
Sir, in the question, it is properly mentioned south, not S. It was written SOUTH. South.
It's a misprint.
Okay, sir.
No wonder you were so confused. Not your fault. It's a big printing error.
Sir, even I was confused for ground speed also. Sir,
What's the confusion?
so in CX3, when I was doing in CX3, it was missing. I was missing ground speed, so I was not getting a correct answer. So is ground speed required for this question? So what? Because ground speed is not given in the question, so what I will put in ground speed option?
Ground speed is not asked here, but ground speed can always be determined with respect to the logic that I've already explained to you all. I'll say it again. You consider the cockpit and your heading, whatever it is, slice whatever your orientation of 360 degrees is, slice it in two halves. Whatever is on the northern part of you, a semicircle, wind coming either from starboard or port, within this semicircle, 180 degree within with respect to my heading, 90 degrees right, 90 degrees left, with respect to whatever my heading is or track is. If the wind is coming within the 90 from here, it will impact as headwind. And headwind does what to your ground speed, students?
So I'd slow it down.
So that's how you get it. Actually, in CX3, you directly get these answers. It's just a velocity triangle based question, nothing else. So you put whatever wind direction you get in the CX3, put your true course, put your TAS. The speed that you get is your ground speed. How to know whether it's correct or not? You should know that with respect to your required track or heading right now, within plus minus 90 degrees, with respect to whatever direction you were on, if the wind is coming, it's going to slow you down. And anything coming from the back, it's going to increase a little bit. The more narrow the wind, the less is the impact. on your TAS or the ground speed, however you want to relate. And the more head or tail it is, the more is the impact.
Sir, but no, sir, I was saying that in this question, we have to find out wind direction and speed to
It is
find out
the
when.
speed, it is wind speed, it is not ground speed. You get it automatically in CX3. It's wind speed. Are you getting me?
Yes, sir.
It's not ground speed. What's happening? Solve it quickly and tell me, Yukti, what's happening?
Sir, I am asking for to find out wind direction and wind speed. Do we need ground speed also? Find out the wind direction, wind speed. Should we know the ground speed?
Who can tell me what are the three pairs in velocity triangle?
Sir, wind vector, ground speed, and TAS.
I don't see pairs.
The TAS.
I don't see pairs. ये तो एक एक एलिमेंट हो गया ना. Pair मतलब दो दो एलिमेंट होता है.
It's a heading and dash, course and ground speed, and wind and direction.
Now I got the pairs. Gulshan, you are partially correct. Yukti, are you aware about this?
Affirm, sir.
So you need two pairs to get the other pair. So you need all information. Okay, you will need ground speed, otherwise your CX3 is not going to give you the answer. Right?
Yes, sir.
So what would you think you would do in this equation? Quickly. Try, think. Everyone, please give me the answer to this question. Your heading is 0980. TAS is 200 knots. And the drift is same 5 degrees starboard. Find out the wind, speed and direction. I want you to try and use your logic quickly. I need the wind speed and directions in the Zoom chat. Come on. Are we getting it? Talk to me, students. If you are confused, I cannot see also. I don't know if you're doing it. So Yukti is raising a very good question. That's sir, is situation mein, in this situation to enter in CX3, what will I use as my ground speed? Any ideas?
Sir, I think this is a wrong question. Is wrong.
It is not. Think, Chaitanya. If it would have been wrong, I would have said. The only wrong thing was starboard was represented as south. You corrected it. Think. Come on, you can do it.
Sir, wind speed would be 44.77 knots and wind direction 72 degree.
Negative. क्या लिया ground speed आपने?
So ground speed 158 knots.
क्यों? अच्छे से पूछ रहा हूँ मैं, एक्सप्रेशन पे मत जाओ. क्यों?
Sir, because I have put every data on CX3. Like earlier we.
पहले heading डाली CX3
yes,
पे.
sir,
Heading आपने डाला.
0900.
हाँ, course में क्या डाला?
Then sir, course 0905 because we have 5 degree.
हाँ, हो गया. TAS.
Okay, sir. And then TAS 200 knots.
ठीक है. 3 एलिमेंट आ गए, चौथा एलिमेंट चाहिए ग्राउंड स्पीड. करेक्ट?
Yes, sir.
तो हमें विंड स्पीड डायरेक्शन मिल जाएगा. अब क्या क्या आ गया आपने?
Sir, I have put this value, so I have got the GS also. Ground speed.
3 वैल्यू में तो जीएस नहीं आएगा. कैसे आ रहा है जीएस आपका? क्या डालिए चौथी वैल्यू? ये ऑलरेडी फेड है तुम्हारे CX3 में. चेक करो केयरफुली. सब कुछ सी करो. लेट एवरीथिंग बी ऑरेंज. वन बाय वन एंटर द 3 थिंग्स एंड देन टेल मी कैसे मिल रहा है. क्विक.
So I put 200 knots only in ground speed as ground speed. So then I get the answer like 17 knots and 180 degree wind direction.
180 degree wind direction.
Yes, sir.
Are you sure?
Affirm, sir.
Check your CX3. Check if all values are correct. Someone had raised their hand. Come on, talk to me, students. कहाँ है? Answers. Where are your answers? Yeah, Karishma, tell me.
There is a formula for ground speed, that ground speed is equals to TAS plus minus headwind or tailwind.
We could have used the formula, Karishma, but we don't know the wind. Wind है तो find out करनी है, तो कैसे determine करेंगे headwind or tailwind है?
Yes.
So let's say my heading is 0900, and if my wind was also coming from 0900, then it would have been a headwind for me. But वो wind तो मुझे निकालना है. I need to find that wind out.
Yes.
So right now in this example, if I'm going east 0900, let's say heading, forget the drift aspect right now. है wind हमें पता है, थोड़ा drift है. Like this, when you're going like this, wind coming from 0900 will be head. Wind coming from 270 will be tail. They will not give you any drift. Okay. But on a 090, you're getting 5-degree drift. And the drift is starboard. It means you're going to be pushed here. It means the wind is coming from here to from your left, from your port. Do you understand what I'm trying to say?
Yes, sir.
So what will be on your port, students? This is for everyone. What will be on your port? 090 से अगर आपके पोर्ट में एक्सट्रीम पोर्ट में क्या होगा? अबीम will be 360. That is 000. If I have to assume, if my wind is coming from any direction, without the CX3, I can assume my wind is coming from 000 or closer to 000. Only then the statement makes sense with respect to what we have been talking about. Are you getting me, students?
So
Are you
I'm
getting me?
getting sir.
Yeah, Yukti, what are you saying?
So I'm getting the answer 17 knots and 002 degree wind
Now, this
direction.
002 is close to 360.
Yes, sir.
Now, that is what you are getting here, correct? Earlier, you were getting the other answer. Why? क्योंकि हमने कोर्स और हेडिंग को ऊपर नीचे कर दिया था.
Yes, sir.
Students, are you understanding? I only got 4 answers so far. Another hint in the question is, continue, I'll tell you, Vishnu Priya, once again. On a true heading of 180, the aircraft experiences no drift. यहाँ पे जा रहा है मेरा एयरक्राफ्ट तो 5 डिग्री स्टारबोर्ड ड्रिफ्ट आ रहा है तो मेरे को करेक्शन करना है यहाँ पे. This is what I'm talking about right now. But if my heading is 180, I'm not getting any drift. It means this another hint can tell me that my wind can either be a tailwind or headwind. For a heading of 180, the tailwind would be coming from 360. And for a heading of 180, the headwind would come from 180. But they're talking about the wind component in one place. If you change your headings. So you have only one wind component with respect to an aircraft either on 090 or 180. 090, drift to the starboard. It means correction applied this side. It means the wind is coming from here. And the wind is also coming from here on 180. See, I get it directly. I'll give you the options. With respect to this particular numerical, option A is wind direction 360, wind speed 17 knots. Option B, please write down the options. Option B, wind direction 180, wind speed 17 knots. Option C, wind direction 180, wind speed 34 knots. Option D, wind direction 360, wind speed 34 knots. अभी हेडिंग की जगह पे हेडिंग ही लिखोगे आप 090 090. तो उस हिसाब से आपका कोर्स if the drift is starboard will be 095. That if you're talking about anticipated drift. Abhi, now this person, whoever has drafted this question, if this person is not thinking like this, then this person will give us the opposite answer in the master key. But that is not true for the language used in our books. So you have to be very careful what you're learning and practicing from.
Sir?
So yeah, I'm coming to that once again. So what is my wind's direction? With respect to here, I can give you a shortcut also. Like I was explaining to you all, anything within plus minus 90 degree of my heading would impact as a headwind, from behind tailwind, Okay. The more it comes from the straight side, the more will be the impact. The more it is 90° to me, the lesser will be the impact. Remember this point also. So my heading is 090 and wind is coming from 002. That's why I can take my ground speed because it is at 2°. I am 090. It means almost 90°. You see, the least effect of this wind is going to be there on your TAS right now. The least effect. When I say least effect, it means your TAS and your ground speed are very close to each other. So in this case, if you want to try some, I would say, techniques, then whenever you have a crosswind component, the impact on your TAS is not much, which means your TAS and your ground speed are very close to each other. The key given to us is 180. So what you can do is, in your CX3, in your TAS, write down 200. In your course, write down 09 or 5. Muskan, go ahead.
Sir, I had a little disconnection. Can you please repeat the options?
Chaitanya, if you don't mind, please give me option A, B, C, D.
Sir, I have not written the options.
Please tell me why.
Sir, I missed two of them. Then I thought I will just see the answer. I'll just find the answer.
Any reason why you did not ask it again if you missed it?
Sir, I thought it will be interruption in between. You were speaking something.
Students, do I scare you? If you have forgotten, then let me tell you the first philosophy. Please feel free to speak up anytime. If you don't want to interrupt when I'm talking, you can always raise your hand. Now, Muskan is doing it since 10 minutes. She didn't feel bad. Even though it was options, nothing else. She kept asking, she got it. She still didn't get it, of course, because Chaitanya didn't write it. So this is why I'm doing what I'm doing, because other places don't give you a voice, not even flying schools. I don't know why would you be like this. चैतन्य, कब से चल रहा है ये सब? कब से बोल रहा हूँ मैं? अब तो फॉलो करो यार. क्या फायदा फिर सब कुछ मेरे हाथ से करके? मैं रख देता हूँ किसी और को मेरी जगह पे. आसान काम है बहुत, लाइन लगी है लोगों की. फिर क्या फायदा इतना सब करके तुम्हारे लिए? when you don't feel free to discuss your doubts and questions and your concerns? What's the point then? पढ़ा तो सब रहे हैं ना, सब बच्चे पास होते हैं जो दूसरी जगह भी पढ़ते हैं. हम अकेले थोड़ी पास कराते हैं सबको. I'm very upset with this, Chaitanya. Say something.
I'll follow.
Say something for a minute.
I'll follow the instructions.
These are not my instructions. This is education. It's universal. I'm just a medium. If you don't like me, students, it's okay. But you have to follow everything I say because it's your education. Please, somebody relay the options to Muskan. Yukti, you do it.
Option A is 360 degree, 17 knots. Option B is 180 degree, 17 knots. Option C is 180 degree, 34 knots. Option D is 360 degree, 34 knots.
All students who are doing RT also, try to use RT techniques in your conversations, okay? Like ending with call sign or relaying this or that. It doesn't hurt. It's not going to waste your time anyway. Muskan, got it?
Affirm, sir. Thank you, Yukti.
Yukti बोलिए welcome तो बोल दूं, but I don't want to interrupt.
Welcome.
Welcome Sky. Muskan, okay, sorry. Muskan, you must have said. Mila सबको answer. Did everybody get it? Nukul, coming back to you, what's happening? क्या बोल रहे थे बोलो. युक्ति, कहाँ गए क्वेश्चन तुम्हारा?
Sir, can you say again? What?
Where did you get the question from?
Sir, Keith Williams.
कीथ विलियम्स में बहुत गलत चीजें दी हुई हैं, इसलिए मैंने मना कर दिया लोगों को फॉलो करने के लिए. I would suggest first 100% eat and digest Oxford. Only then go for Keith Williams so that you know कहाँ गलतियां हैं, कहाँ गलतियां नहीं हैं.
Confirm, sir.
It's good for practice, but the problem is there are a lot of errors. So कुछ अच्छा करने के चक्कर में आप खुद पे ही डाउट करने लग जाओगे, because कितने एरर्स है देखो यहाँ पे क्वेश्चन में. मास्टर की में भी शायद गलत ही आंसर दिया होगा. क्वेश्चन देख के मैं समझ गया कीथ विलियम्स क्या है, बट आई थॉट इट कुड बी ऑक्सफोर्ड, बट आई न्यू इट इज कीथ विलियम्स. एरर देख के बता दिया. Oxford is enough, students. Keith Williams is fine, but first Oxford, then Keith Williams, so that you can spot the errors. जैसे अभी चैतन्य ने बोला, so question गलत हो सकता है. Of course, sometimes the question could be wrong, but not always. So you're not in a position to figure that out yet. So you don't do that. Oxford barely has some mistakes. Oxford also has some mistakes. I know which where, but barely. It's okay. Everybody makes errors. I make so many errors. Nobody does it on purpose. Anyone who's thinking, sir, लेक्चर का टाइटल तो स्केल है, बट आप स्केल कब शुरू करोगे, मेरा टाइम वेस्ट हो रहा है. Anyone who feels like that, just drop me a message personally, WhatsApp. Honestly. Anyone who's thinking the past 2 hours has been a waste of your time because either you already knew it or either you wanted to learn something new under the pressure of exams and syllabus completion, drop me a message right now. I need to know. I need to know how you feel so I can improve things for you in your favor. But if you don't tell me what's bothering you, honestly and directly, then how can I help? Nukul, can I kuch? You want to say something? Karishma, here,
So here,
yeah, tell me.
so here we need ground speed. Then we able to find out the uh, wind direction and wind speed.
तो आपको पहले क्या डाले थे आप? कहाँ से मिला था पहले सब कुछ आपको?
Sir, I don't know. I think it was previous value.
नो प्रॉब्लम. मुस्कान, कैसे आ रहा है 18017 तुम्हारा?
As you said, because of that 90 degree है तो फिर वो टैस के बहुत ज्यादा सिमिलर होगा ना, वैसे आया है.
तो आपने टैस लिया 200, आपने ग्राउंड स्पीड लिया होगा 200. ट्रू कोर्स क्या लिया है आपने?
095.
एंड ट्रू हेडिंग क्या लिया है?
090.
चेक करो क्या आ रहा है आंसर्स. क्या ऑप्शन मार्क किया और CX3 में क्या आ रहा है? Chaitanya, are you able to solve this or not?
Sir, I'm not able to understand what will be the ground speed.
Okay. Muskan, cross check your answer quick. Likit is saying, sir, I can put in the options one by one and check for the course because we know the course, right? Of course. That is another way to solve complicated questions. Reverse calculation. Of course, you can do that. That way, there are chances that you might not miss out on any question if your logical reasoning is right. Always you can do that. That's actually one of the secrets to make it much more easier in the exams. And I've discussed it quite long before. If you all don't remember it, now is the time to remind yourselves. If nothing, reverse calculate to find what is given in the question. To determine my ground speed.
Sir, by doing this, we are getting 200 as the ground speed.
Exactly. So हमने directly कैसे ground speed derive किया है? How did we derive ground speed? Two things from the question. Okay. It's always looking at the question that you will get hints. 090 drift, both are actually happening. And then the hint is given to us that if you are following 180, then there is no drift. That is the hint to find out your ground speed. One thing we learned today, forget the past, is that when your wind component is very cross, it's not going to impact much of your TAS. As in, there will be not much of a difference between ground speed and TAS. If you are like this, wind is coming exactly from right, assume no impact on your TAS. But the moment it starts from here, 1 degree, 2 degree, 3 degree, 4 degree, 90 degree, the moment it starts coming face on, the impact will become higher and higher and higher. There are two hints given in the question. Anyone who has not written down the question, do you want me to show you the question again? Chaitanya, do you have the question properly?
Yes, sir.
So I know first thing with respect to the question that my drift is from the port when my heading is 0980. So for me, my port, when I'm at 0980, my port is what? Isn't it 360? Chaitanya?
Yes, sir.
It is, right? It could be anything from 360 up to 089 or something, right? This is exactly what we're talking about. Are you with me on this point?
Yes, sir.
So it's on my left. So I know it could be anywhere in this side, my left side. First hint. Second hint, if I'm following 180, I'm not getting any drift. What does it mean? Just look at this point now. On a heading of 180, no wind experience, no drift experienced. What is the wind direction? It could be either headwind or tailwind. Yes or no, Chaitanya?
Yes, sir.
Right?
Right, sir.
The hint here is this and the one that on my left. Now come back to 090. 180, headwind, tailwind. On a heading of 180, headwind is 180, tailwind is 360. Right, Chaitanya?
Right, sir.
Now, how do I figure out whether it's 360 or 180? I look at my heading and I look at my wind direction. Wind is coming from port. My heading is 090. Port will be, what will be port for me? Will it be 360 or will it be 180?
Sir, on 180 heading.
On 090 heading.
That will be starboard. 360.
360. 360 लेफ्ट में है ना, स्टारबोर्ड में कैसे हो गया? लेफ्ट से आ रहा है ना विंड.
Yes, sir.
ड्रिफ्ट स्टारबोर्ड है तो करेक्शन लेफ्ट में हो रहा है ना.
Yes, sir.
तो 360 से आ रहा है मेरा विंड. और जब मुझे पता है 360 से आ रहा है, अबीम आ रहा है, तो मैं मेरा ग्राउंड स्पीड ले सकता हूँ as close as TAS, because the difference is 90 degrees between my heading and my wind speed. And the difference is 90 degrees or close to 90 degrees. The effect is bare minimum.
Okay, sir.
It's a trick question. You might seem, sir, ये तो बहुत lengthy process है, but this is the logic that they want you to seek in such questions. Such are the hints, students. If I have to make you a moderator, you will have to use your logic to create confusing questions for us. 10 people, 1,000 different questions for the same point. So how am I using ground speed as 200 here? This is the relationship. That if the crosswind component is there, my TAS and ground speed are very close. This is the takeaway. But how did we get this takeaway? By breaking down the question and understanding everything in the question, one by one. And once I enter my ground speed as 200, I finally get. What do I get, Chaitanya? Now, can you give me your answer, please, from the options? Chaitanya, if you need the options, I'll ask someone to relay.
No, sir, I have it.
Give me your answer. Everyone who has submitted wrong answers or incorrect answers, confirm. So, Muskan, option match karo. Tumhara answer to aa gaya hai. Students, you will get your answer from the options. You have to choose the closest answer. Another logical reasoning. If CX3 is giving you 002, in the options you don't have 002. And you will think 002 is very close to 000. But no 00 is there. Only 360 is there and 180 is there. Then you need to realize that 000 is also 360. So it's now option A is not 000, it's 360. We have to be very focused. Chaitanya, समझ आ रहा है नहीं आ रहा? Confusing है, I understand. Take some time, but tell me, आ रहा है नहीं आ रहा समझ?
Sir.
मतलब नहीं आ रहा? बताओ क्या नहीं आ रहा समझ में, अच्छे से बताओ.
No,
बात
sir,
बताओ. Talk to me, what's confusing you?
Sir, it is saying that the task and the ground speed will be approximately same when in this type of situation.
What type of situation is this?
Then
Take your time, no rush. Everyone who was getting 180 earlier, whoever has submitted, either correct it or talk to me about your confusion quick. This is exam level prep. This is what happens. You sit, you discuss, you think, you solve, you dive deep. चैतन्य अभी रिलेशनशिप बाकी है बताने. लिखित ऑल ओके. नुकुल, प्रेरित, रोहिता, विष्णुप्रिया, श्रीधर, गुलशन, चैतन्य बताओ कहाँ कंफ्यूज्ड हो. फिर लंच ब्रेक लेना है सबको.
yes sir.
कीप टॉकिंग. म्यूट पे मत जाओ अभी, अनम्यूट पे रहो. क्या चल रहा है दिमाग में, क्या कर रहे हो, बोलते रहो मेरे साथ, सबके साथ. इट्स मी, इग्नोर एवरीवन एल्स. Students, are you building confidence? Are you working out a few things on the CX3? Yukti, everyone else, or you're just sitting idle waiting? Nobody has to sit idle. Keep doing something or the other. Keep talking. And I've already advised, keep playing with the CX3. Get to know it. Get to know it as if you're studying for MBBS and CX3 is the body. You need to know everything that exists, whether it's in syllabus or not, to get that extra 5 points. चैतन्य, चलो, टाइम्स अप. टेल मी, क्या चल रहा है. उतना आपने बोला सही बोले, बट वो क्या रिलेशनशिप है जहां मैं अज्यूम करूंगा ऐसे सिचुएशंस में माय टायर्स एंड ग्राउंड स्पीड विल बी क्लोज टू ईच अदर. What is that point? Just one explanation. It's very easy. Try to explain in your own words. Any language is acceptable.
Sir, sir, I partially got it, I guess. That's why I'm not able to tell you.
So I'll help you get the final thing. Make a note of it, Chaitanya. Whenever the wind is coming from, we call it crosswind generally. You can say if the wind is at crosswind, either from right or left, port or starboard. That is, i.e., whenever the difference between the heading or track, whatever you want to take in this case, whenever the difference between the heading and the wind direction is within plus minus 90 degrees. Okay.
The heading and?
Whenever the difference between the heading and the wind direction is 90 degrees, not within also, is 90 degrees or close to 90 degrees.
Okay.
Then the task and ground speed will be very similar. अच्छे से लिखो. Everyone write it down. You're very lucky ऐसा ऐसा आपको डिक्टेशन मिल रहा है. So many ways to understand one same thing. You're very lucky students. चैतन्य लिखा पूरा, रीड बैक दो वापस, आप दोगे रीड बैक? चैतन्य म्यूट पे हो आप.
Yes, sir. I have.
दो रीड बैक दो जल्दी, फटाफट.
Sir, when there is 90 degree or close to 90 degrees difference in between the heading and the wind direction, then we will take the TAS and the ground speed or approximately the same.
इस केस में हमने कैसे फिगर आउट किया? द हिंट वाज on a heading of 180, no drift. So we knew that wind is either coming from 180 or 360. How did we determine the wind is coming from 360? Because it was port. The wind is from port because of the starboard drift. So actually, in the options, direction of the wind I get this way only. All I need to find from the CX3 is the speed. That's 17 knots. And then to verify your answer, you see your answer is close to 360,002. So 360 तो बिना CX3 के ही पता चल जा रहा है, लॉजिकल रीजनिंग से. चैतन्य, आ रही बात समझ में?
जी सर.
अब बोलो, पार्शियल है कि फुल है?
हाँ सर, फुल.
हाँ, झूठ बोल रहे हो. कोई बात
नहीं सर.
कोई बात नहीं. You're just nice. That's why you do such things. I know. I don't blame you. You're just very respectful and nice. But no, be rude. Be rude if you have to. Break all the doors to clear your doubts. Be a Hulk. Chalo, good. Any doubts? Anyone? After this, the only thing left would be to give you some numericals to solve. If you are always confused again and again, then I would ask you to revisit this session and try and solve. Because एक ही चीज बार बार बोल के क्या फायदा है, right? But yeah, after you have tried and if you still don't get it, then definitely you will be discussing with me one-on-one. So don't think that आप लोग को भगाया जा रहा है, doubt solve नहीं किया जा रहा है. Please. When we ask you to do something on your own, you have to try diligently, religiously, willingly, but with a new approach. If you have the same approach, then no point. Say, sir, मेरा approach change नहीं होने वाला, same होने वाला. आप क्यों नहीं बता देते direct? You can say that. I'm like, okay. No questions? This is the most important aspect. You understand this? Afterwards, it's only a matter of targeting questions. And yeah, connecting it with RB, QDM and all, which we will definitely be doing numericals. So don't worry about it. All I want you to do right now is understand. And from this question, we have learned a new thumb rule. So this statement, when the difference between the heading and the wind direction is 90 degrees or close to 90 degrees, the TAS and GS will be approximately be the same. This is a thumb rule we have figured out right now. Make a note of it. Okay. So I'll see you in 30 minutes. Let's learn what is scale. Okay. Scale can be one of the most confusing topics if you don't focus. If you focus, you can master scale in 10-15 minutes. All right. So 2 o'clock, come back everyone. Is that fine? 30-minute break. Anybody wants to break till 2:30? Khana ready nahi hai jiska. Anyone? 2:30? Fine. 1400. Come back. Okay? Chalo. Welcome back, everyone. We are missing two. We are missing two pilots. I don't think there's ever been any story about missing pilots. Like, who is missing? Yukti is missing. And I think Rohita is missing. No, she's here. Nukul. Okay, fine, got them. Students, 30 minutes was too less, yeah? You should have asked for more. But it's okay. I should have given you 45 minutes. Didn't even realize myself when it passed on. I wanted to give you an extension, but I thought it's okay. By the time you'll check your phone, you'll be sitting on the table only, I'm sure, study desk, whatever you're using. Like, it's okay. So students who have been requested to keep your videos on, especially with your exams, make sure you do that from next session so that I can see whether you're following or not. And I don't have to keep asking you again and again and wait for your responses. That actually delays the time a little bit more. But with your tone, I can speculate that you're confused, you're not getting it, or you're struggling. But your body language would be much more easier for me. And I can focus more on you individually in the session also. So please make such arrangements. If you have strong privacy issues, then I would understand. Otherwise, please. And in case you have strong privacy issues and you don't want to do it, anyway, if you don't want to do it, then you have to respond me every now and then via text. Because I am checking. Even though you see my eyes moving here and there all the time, what do you think I'm looking at? Just your accounts, as if I'm looking at all students. Waiting for any expression. If anybody gives me this expression, it tells me they have a doubt. If anybody gives me a weird, anything can work. The acknowledgement is very important now that you have your exams in a few days. So please remember. Okay. So what do you know? What do we know about scale? This is a scale, right? We have seen it all our lives. We generally use a scale for drawing straight lines and, of course, measurements. So we have units on the scale. This basic scale has 2 units. One side is centimeters, second side is inches. Why do we need to learn scale? Why is scale so important? Are we talking about this scale in aviation? Yes and no. Yes, somewhere it has relevance. No, because we are not talking about an object. We are talking about a relationship. Everywhere in the world, there are scale models. This is a scale model of an actual Boeing 747, but this is not accurate to scale, but it is close to accurate. The ones that are accurate to scale are very expensive and very fragile also. Anything can be scaled down. If you have happened to have any experience with respect to an exposure in real estate, you see that when a project is being developed, they make small buildings, as if a school student has made some school project, but top level. You see as if a real building is there on a small piece of table, right? A big complex. Everything looks so real. Why? Because it's to scale. That's why. Everything is to scale. What is that scale? So let's say in that house model, one room is of 1 square inches. So how would I understand what is the scale comparison here from the actual building and this? I can say the actual room will be 1000 times this. So what is 1000 into 1 square centimeter? I'll get 1000 square centimeter. So I'll get an idea. All I need is the value referred to as scale. Something can be scaled down or scaled up. Generally, things are scaled down only. from a bigger value so that it can be compact. In other words, when we talk about scale, how is it applicable in navigation studies? How is it applicable in aviation? The application comes with respect to the charts that we use to fly. Although in your syllabus and in your learning, you don't do a lot of chart related practice here. The same thing, DGCA doesn't really emphasize much on that. But assume that you have been doing charts, because that's how you learn. You learn plotting. You learn how to make a flight plan, how to plot everything. What are these charts? Generally, these charts have a publisher known as Jepson. Just like we use WGS 84, model of the Earth, World Geodetic Society 84. We use their model in aviation, all the computers, softwares, programs, instruments, charts. So this Earth has a circumference of how much? 10 km plus, correction, 10,000 km plus 10,000 km, that is kilometers, plus 10,000 km. 40,000 kilometers is the circumference of the Earth. 40,000 kilometers. I'll have to make a chart that would span for 40,000 kilometers. It's not possible. It will cover the whole Earth. Not possible to be carried in a plane. What do? I make small charts. This small. This small, this small, this small, this small. How small do I make charts? The idea how small do I make charts you get from the scale. Generally, it could be written down as a ratio. One will always be first. The two dot mean is 2. The first ratio that you see below Jepson, 1 is to 50,000. This figure here tells me the scale down value. That I've scaled down the chart, not half. Half would have been 1 is to 2. If I would have made half, the circumference that I would have had to show and everything on the Earth would have reduced by half. So for me, whatever I'm doing, let's say I have to make the circumference on a chart, anything related to that would come down from 40,000 kilometers to 20,000 kilometers. Is 20,000 kilometers practically possible to be carried in the aircraft? Not at all. The weight itself will kill, even if we can create the paper that big to make a chart. So if I further reduce the size of the Earth to be plotted on the chart, let's say instead of half, I make it in quarters. That is 1 is to 4. Still 10,000 kilometers, not possible. So what do I get that makes it feasible for me to make my charts so that I can use them for references? And why do I need charts? I need charts because my charts are my Earth that I'm following or tracking. Charts are the representation of the Earth, accurate representation of the Earth, accurate to the point. How accurate? Everything is so close by. One airport, second airport, it's like this much. How can this be accurate? It is accurate because if the chart is scaled down, everything is scaled down. Everything, even you, the aircraft, everything. And when you will go microscopic level, if you'll go to the atomic level, you will see the speed, distance, time will be the same, even in this much of distance. In other words, these are your general scale down values of the Earth's real size to the chart. Either we reduce the Earth's dimensions by 50,000 times. So we divide, let's say if it would have been for circumference, we would have divided the circumference 40,000 by 50,000. Whatever we get the value, that particular value would represent our circumference over there on the chart. Are we getting it, students? Only Rohita is getting it. Prerit, Nukul, I can assume because they are not nodding no and they are not saying yes. So I can assume it's a yes. Yeah, we'll stick to that. If you don't have doubts, you'll not say anything. We'll stick to that only. It makes it easy for us to acknowledge. Chaitanya, are you following so far?
Yes, sir.
So the ratio is actually, when I say 1 is to 50,000, it actually represents this fraction. 1 by 50,000. This fraction, in terms of scale, is called as RF. RF stands for representative fraction. Nothing else. In your exams, in your books, anywhere you go, you might be asked about scale, you might be asked about RF. Both are one and the same. RF represents the scale. Scale is represented in a ratio. That ratio is called as RF, representative fraction. The word representative means, in this case, dimensionless. It means the fraction is just the ratio or the fraction is just showing me the relationship. It is not giving me the units. The units will be mentioned somewhere specifically. What unit is followed? And that unit is scaled down to be made into a chart. Generally, it's centimeters. But any unit can come. You will get a few scale questions. They'll be confusing because they'll play with a lot of units. And then they will ask you what the fraction is. There are many techniques to do it. I'm going to give you the easiest and the best technique. When you go through Oxford notes, you will see another technique where you need to depend upon your memory, but you don't need to because you have CX3. So we can save that much of hard work. And that is nothing but conversions. This RF, this scale version of RF is the most important version of scale that we have. But this is not the only version of scale is represented. Scale is represented in 3 ways. In words, in graduations. This is exactly what graduations are. And then RF. Are we following? Anyone who is still alien to what is scale so far? Raise your hand. But before we come to the numericals and the solutions to see actually how the scale questions would be like, we need to know something called as RE. RE stands for reduced earth. The first time I came across this term, I was in love with it. Reduced earth. Wow. Who would have thought about it? Imagine man's confidence to map the earth and then reducing it down to get accuracy. And imagine the level of genius behind all these things. What is reduced earth? This is earth. Is this real earth? Is it expanded earth? Or is it reduced earth? Sir, it is real earth reduced. It's realistically reduced earth. This is exactly what reduced earth is like. All I need right now is to know why I need this reduced earth. To understand scale and to understand why I need reduced earth, I need to know how are charts made. In olden times, when we didn't have computers the way we have today, when we didn't have softwares, everything was mostly analog. I'm not sure about everyone, but we all have somewhere or the other seen a Xerox copy come out of a machine. There is a feature in the Xerox, reduction, that children generally use to carry chits in the exam to copy, and expansion for projects or maybe clarity of reading. The reduction from 100 to 90%, 80%, 60% is nothing but your RF over there, scale down. Although the Xerox machine is so complicated, the basic idea is it sheds a light on a new paper, and whatever is printed on that paper will be copied and printed on the new paper. There is light. We need light because light will give me shadow. That shadow will give me the shading, and the shading will give me the print, something like that. In earlier days, when we were in schools, the highest level in school, okay, not even college, and I'm not talking about way too far because I think you all know how old I am. The most advanced way of learning in class was through projectors. The projector was a very interesting machine. We had blank piece of plastic sheets, transparent of this size. On that, people used to write in permanent marker or maybe print, put it on the projector. Projector had a lamp connected to electricity. And then we needed a projection screen. And then we can magnify anything on a small piece of paper to share with a larger audience on the whiteboard. It had its limitations, but it has given a lot of education to everyone for a lot of years. That is projection. Projection can be done to increase or decrease the size of any particular thing you want to communicate, but it is always in print in one or the other way. Another example of projection is when you go to watch a movie in the theater. The movie in a theater comes from a small film this size, 35 mm, I guess. Genius, right? You get 4K, you get 8K, I don't know. Avatar, imagine level of clarity coming from this short film. That's projection. But you need a print. We call it fine print. when we had to make charts for our references, we use the same technique. To make a chart, first we needed to scale down the model of the Earth. So maybe we did this. Then inside this Earth, we put a light source. Outside, everything is printed to scale as if it were real Earth as per WGS 84 model. And then wherever the shadow came, we could take a print out. If I need the chart to be of the North Pole, I will get the shadow in a way that the North Pole area is printed on the chart. If I need the areas to be printed be on the equator, then I would place it in a way that the shadows are projected on the chart to resemble the equator, or maybe any other point that I need. That is projections for you in navigation studies. Projection is an old technique. These days we use computer models to generate charts. But just like anything else, you have to study this, you have to know this. The charts made directly with projections like this, direct, lamp and that reflection, Xerox kind of a thing, direct. Those are called perspective projections, or charts produced like that are called perspective charts. And those charts which are made through computer models are known as non-perspective charts. Students, make a note of these things, okay? I don't want to write everything for you on the whiteboard. So I get two types of projections. First, I will reduce the Earth to a scale down value. Then in the reduced Earth, I'll put a light source to get my projections. So my projections become either perspective or non-perspective. Don't use layman's logic here. The names are very confusing. Understand and see everything as if it's the first time. Don't use logic. Just learn right now. Perspective is pure projection. Pure projection charts. Non-perspective is charts with mathematical calculations. These days, you are told to agree on a point, which is non-perspective charts can also be called as perspective charts. Charts basically derive from direct projection, that is perspective. Non-perspective can also be termed as perspective charts with mathematical calculations. Now, if somebody ever asks you which chart or which projection do we use in aviation, you will only say we use non-perspective charts. Projections with mathematical calculations, computer models, everything will go in non-perspective then. Jepson charts, non-perspective. Aviation charts, non-perspective. You can say perspective charts, perspective projection, one and the same. Now, be it perspective, be it non-perspective, you only have limited types of projections available. And those types of projection give you different types of charts. And different individuals have created these different techniques over the period of history. and the projections or the charts are named after them. You must have heard about Lambert. You must have heard about Mercator. Mercator is equivalent to, I would say, Columbus, I guess. And the other guy, forgot his name.
Vasco da Gama.
Yeah, I thought I got it wrong. Mercator really did some wonders with respect to plotting and understanding the Earth and printing it back on chart. He was regarded as one of the greatest explorers. Many people have lost their lives mapping the Earth. Many people have lost, never to come back. Many people, there are movies made on people lost in Amazon and so many other places. I personally believe, on a side note, there are many places still undiscovered. But now, with satellites, I think every part of the Earth is scanned. So now, probably Google Earth, any other Earth model gives you basically GPS and satellites have taken this way ahead. What you're learning is the invention right now, but it is important for your exams. So depending upon what part of the Earth with respect to the graticule, depending upon that, you choose what kind of projection you want. There are 3 kinds of projections. And depending upon where you want more accuracy, which area, which graticule. Now, with respect to graticule, I can convert or I can divide it in 3. Equator, that is 0 degrees, north-south. Mid-latitude, that is 45 degree, north-south. And polar region, that will be 90 degree, north-south. I get these 3 classifications. If I need more accuracy near the equator, plus minus 10, 20, 30 degrees, whatever you will learn, then I need a projection suitable for this only. And there's only one projection suitable for this. If I want more accuracy for charts for midlats, then I need another type of projection. And when I need more accuracy for polar regions, North Pole, South Pole, I need a different projection. I don't remember when was the last time I saw a chart in my life, but I think it was an atlas. And if I go back in my memory, we were very, very, very young. I think primary, I don't know, it's standard. But we used to get a lot of books from people who had passed. Like they used to sell it in the, what do we call them? You know, we sell books and paper, right? What do we call them? I forgot. In English, what do we call them? So we used to get it. When we saw the atlas, I remember we were so excited to explore the world through the atlas. It was a projection. And then the second time I saw, I think it was maybe in school or somewhere, I saw a big blue chart showing the Earth. One nice big, where I see big Africa, big North America, South Africa, South America, big Greenland, and big Australia, big Asia. Everything is so big, big, big. And you will see all across the world, that kind of map is universal. That projection is called Mercator projection. Everywhere in the world, a common assumption is that Mercator charts are true charts. Mercator made that. So we follow that. But it is not real in all places. The ratio of Africa, the ratio of Greenland is wrongly depicted with respect to other land masses. This is a flaw in Mercator projection that you will come across. when you read. That's why we needed other kind of projections. Most of the times, nav charts will give you Mercator charts only. But then the accuracy varies. So no matter what projections you will learn, there will be common points that you'll have to memorize for these projections, and your job becomes much more easier then. How do I get the print from a reduced earth and the light source on a flat sheet of paper? The projections are so easy to understand. If I have a plain paper and I keep the paper plain to get my projection like this, near the earth, I call it plane projection or azimuthal projection. Whenever I do this, make a cylinder out of my paper, a complete cylinder, like this, I call it cylindrical projection. And I sometimes have to make my paper like a cone to eat some nice beachside snack, bhel puri or something. I don't know about y'all, but in Mumbai, we love all these things, bhel puri, sev puri and all. It's just so divine. I mean, I can feel the taste of, I skipped my lunch, so I'm now thinking about bhel puri with this cone. I call it cone. We see it in ice creams and all. Exactly like this, a cone is made and the cone is kept somewhere to get the projection out. We call it conical projection. So we have got 3 types of projections. If someone asks, cylindrical projection gives you accuracy where? It's the equator. Mid-latitude's accuracy is achieved through conical. And polar regions is achieved through plane projection, also known as azimuthal. Azimuth means horizontal. So the cylindrical is also called as Mercator. Conical is related to Lambert, another guy who fixed the problems that were existing in Mercators. And then the 1 over polar are called polar stereographic. Every type of projection has its own advantages and disadvantages. And the concept of scale is not always the same in all projections, especially Mercator, because Mercator is what we widely use everywhere. So when we learn scale, we need to understand that we have to first understand scale in basic terms and then its applications on different projections. Think, students. Tell me if you have doubts. Perspective, non-perspective, 2 classifications of projections. 3 types of projections. 3 different names or 2 different names and accuracy, which latitudes. What is scale? RF, representative fraction. Dimensionless, it just shows you the ratio. Unit could be anything. Generally, centimeters are used. But you have to determine in nautical miles. You'll always have to do conversions. Where would you do conversions? You'll do conversions on your CX3. I want all your CX3s on top. And I want your scientific calces also. I want both your calcs, separate places. You can use your phones, whatever. If you don't have multiple devices, then you'll have to tally. It might slow you down a little bit. Let me know. I'll give you some time then. We have to get into exam mode. In exam mode, you will have two calcs, CX3 and scientific. CX3, in this case, you will use for conversions to get one element. And in the scientific calc, you will keep feeding that converted value one by one. You don't have to write it on a piece of paper, the numericals. You can do it, but with practice, you'll be able to learn it to do it directly on the scientific calc also. But before you do the calculations on scientific calc, you'll have to do conversions, which you will do in CX3. Only then you will get your answers correct for questions based upon scale. Otherwise, you'll be very confused. Anybody who wants to be confused? Let's go back a little bit. Let's go back to the first few lectures that you have studied in navigation. Let's go back to the day when we learned about what are longitudes, what are latitudes, what is convergency, what is a great circle, what is a small circle, what is a rhumb line. Let's go back to that time when we realized that a great circle direction or a track is very important for a pilot to know. And so is rhumb line, and so is convergency, and so is departure. 4 elements. For the Earth, we know. If you can recall, two ways to determine two meridians in the northern hemisphere. Based upon how we are making it, is the great circle a curved line? Is the great circle a straight line? Is the rhumb line a straight line? Is the rhumb line a curved line? Please revise if you haven't revised those parts. This is Mercator, straight lines. You will learn about it. This is realistic. So as a pilot, it will be very important, students. As a pilot, it will be very important for you to know how does the great circle and rhumb line apply to these different type of projections. Probably some formulas. That's where your learning about projection ends. I'll say again. Look at that, a disconnection. So as a pilot now, for you, just the basic great circle, basic convergency, and basic rhumb line is not going to be complete. You might also be asked about great circle, rhumb line, convergency, scale with respect to specific projections also, and mainly Mercator. This is your ultimate goal in learning projections, remember. And finally, you need to read the scale for these charts. So now we know why we are learning scale. Because we need to know the unit on the chart, 1 centimeter or 1 inch, small. It could be 1 mm also. It will be too small, 1 mm, for anyone to see visually. Understanding that unit, how can I calculate to find my distances in real nautical miles? This is the application practical. How will you as a pilot, during your flight planning, use your charts while plotting to determine realistic directions, or in this regard, realistic distances? So you need to know how much is 1 unit on the chart, actual nautical miles on the Earth, or actual statue miles on the earth, or actual kilometers on the earth. They can play with your mind. This unit could be anything. Will RF give me the unit? No, just a fraction. But yes, the unit would be mentioned somewhere. If you don't understand the practical application of any concept, your learning is incomplete. Aviation is one such field where everything you learn is 100% applicable practically. So now you know why you need to know RF or scale. The realistic reason you need to know scale is to determine your real distances on Earth, to calculate your speed distance time, to calculate your fuel, to calculate your ETA, other part of your navigation. One was staying on track. Second is this. If you wrongly calculate your distance from me to Nukul's place of party, then I'm gonna increase my chances of accidents. So I need to know what is scale and how do I convert scale into realistic directions on Earth. And then I apply that to my flight planning and I cross check. Only then I'll file a flight plan. Anyone who's not getting it, this is the meaning. And this is the first most important definition of scale. Scale is chart length upon Earth distance. And the ratios that we were talking about, one shows you 1 unit on the chart, and the bigger number shows you the actual distance on the Earth, called as Earth distance. But remember, scale is also RF. Therefore, RF is equal to chart length upon Earth distance. Now, this is more important than the scale definition because numericals will come with respect to RF, although they are talking about scale. CL will stand for chart length, ED will stand for Earth distance. The secret to get all answers correctly is to keep the same units. You will have to make your mind run here or there a little bit to get the correct answer initially. So don't expect too much from yourself to get answers directly for certain questions, but give yourself some time. Do not rush. When we rush, it takes some time to come to us. And if we rush, we get disappointed. Because if we are not getting a concept while rushing, we get disappointed. And that scares us. And then a domino effect of negative emotions, feelings, or whatever that affects your studies. So I'm setting the expectation direct. Be patient with some of the numericals I'm going to give you. Try and try. Think. Any doubts? Any questions? What is scale? There's a pigeon. I think he's here to check if I'm teaching how to fly correctly. Usko to aata hai. Why would he attend a class? At first I thought he or she is also learning. Then I realized no, they are masters of flight. किसने भेजा उसको? Whose detective is he? Who's cross verifying? Big one, huh? I'm scared, they get inside. If they get inside, they'll injure themselves. So if anyone ever asks what is scale, see, in between, if you don't get my jokes, it means you have lost focus. Okay? So that's a reminder for you to wake up. Otherwise, some people say they like listening to me, so that will put you to sleep, especially after lunch in an afternoon session. So what is scale? It's a relationship between underline the length of a line drawn between 2 points on a chart and. So here before and in bracket you will write chart length. It's a relationship between the length of a line between 2 points on a chart and the actual distance between those 2 points on the earth. Another way of putting the same thing. You need to know all kinds of explanations to all concepts because questions could be theoretical or numerical or fractional. So we have to be prepared. I'll say again, what is scale? Likit, make a note of it. It's a relationship between the length of a line drawn between 2 points on a chart and the actual distance on Earth between those 2 points. And this is what we call as Earth distance.
So scroll up a bit, sir.
Yeah. Chaitanya,
Sir.
talk to me.
Yes, sir. So should I give a feedback or something?
Anything you want to talk about this? Whatever. Maybe doubt, maybe anything. Affirmation, acknowledgement, whatever. How you feel. Getting, not getting. That's
Yes,
it.
sir.
Talk to me.
Getting it. Following.
Good. Partial, full.
Full, sir.
Good. Very good. कोई डाउट है तो बताओ.
नहीं सर अभी.
Muskan? All okay?
Affirm, sir.
Karishma?
Yes, sir.
Are you getting everything?
Affirm, sir.
Students who are almost asleep, don't raise your hand. The whole class is almost asleep. Only Muskan is not. Some people realize what I said now. नकुल प्रेरित हाथ तुम्हारे दिख नहीं रहे, तुम्हें भी यूज करना पड़ेगा. आंखें खुली है तो क्या सो नहीं सकते क्या? So Likhit and Gulshan and Rohita, half asleep, huh? Should I send you some coffee? नकुल, गुलशन कॉफी के लिए बात कर रहे हो? टी, टी, चाय. Good, good, good. So students, make a note. Scale can be expressed in 3 types. Okay, scale expression, we can say how to represent or write scale. The first is a simple statement in words. Second is graduations, a graduated scale line. We see this quite often in many of the charts, survey charts. Generally, we see this. Wherever you have to represent latitudes and all, I'll show you examples of these. And the third is RF, representative fraction. So representative fraction example, you know, and we are going to do numericals based upon them only. Statement in words, write down an example. One centimeter to 10 nautical miles. Like this. In simple words, it will mean 1 centimeter on the chart will mean 10 nautical miles on the earth. So if I'm plotting, let's say, my destination to the party of celebration, success party. Let's say the total distance to travel is 100 nautical miles. So when I'm plotting on my chart, I would have drawn a line of 10 centimeters. Do you get it? If this is the scale. Nakul, Prerit, did you just listen to what I said? So let's say my distance to go was from A to B, 100 nautical miles. And if this would have been my scale in words, 1 cm to 10 nautical miles, then what would be the chart length for 100 nautical miles? The chart length would be 10 centimeters, correct? That's what you get when you're plotting. So talking about the logical step-by-step process, first you get the chart length, then you check the scale, then you apply the conversions, and you get the real distance. That's how you get your distance to fly. Based upon that and Met report and flight level availability, you determine your speed based upon your specific fuel consumption, the best use of fuel. And based upon that speed that you choose, you get your total estimated elapsed time. How much time will you take comes last. Generally, Mumbai to Delhi, if I say it takes 2 hours or 1.5 hours, I could very well do it in 45 minutes also. It's possible. The plane is capable of flying that fast. God bless you, Nakul. But it's not economical. So time we get the last thing. Please, students, be aware of these things. These things are what's going to help you get your jobs in the long run, clearing interviews. Our whole goal is that papers are just a byproduct. But of course, the focus is on papers first. We are giving you a lot more than you are asking for. Because I want the future of aviation in India to be the best in the world. And you are the future. This is my mission. Graduated scale, something looks like this. They'll show you what is the meaning of one graduation. Generally, in your textbooks, you will see they will give you latitudes. Like there's one example. If this is 59° north and that is 60° north, then we know that 1 degree latitude, semi-great circle, 60 nautical miles. So if I have 1, 2, 3, 4, 5, 6 divisions, then every division will be 10, 10, 10, 10 nautical miles for me. Of course, some are small and some are big. Of course, I've not made it accurate, but you get the idea. So here, this will mean 10 nautical miles. This will mean 20 nautical miles to 10, 20, 30. This is graduated scale. See, everything you have to connect with the basics. We have covered everything in your basics. So you are safe. But you need to know the importance of those basics. They are not basics. They are the core. Everything is basic, basically. Wordplay. Huh? And now we come to RF. So get your scientific calci, CX3 ready, notebook ready. Calculations, calculations, calculations. Confusions. That's all we have now. Take your time. Do not rush. And talk to me if you're confused. Especially those students who are giving exams in March. These things, master them right now. Try to do that. Otherwise, when things become complicated, we are like, okay, we'll do it later, later, later. But the way we are teaching you, the plan is to help you study right here, right now. Sridhar, please go ahead.
Sir, no doubt, sir. By mistake, I raised my hand.
Okay. No, not by mistake. Maybe वो पहले मैंने बोला था ना. I had said first do it. Probably then. If somebody ever tells you what is RF, okay, so there's a statement to that. Make a note of it also. Okay. And remember, it's dimensionless. Okay. Just like perspective, non-perspective charts can be said to be perspective charts with mathematical calculations. Okay, Vishnupriya, I hope you can hear me. So there is a statement to, yes, yeah. So there's a statement to RF, representative fraction. Just like we can say non-perspective charts or projections are derived from perspective charts with a combination of mathematical calculations, representative fraction can be said to be a scale expressed as statement in words, and that statement in word converted into a mathematical expression, that is RF. You need to know these words because sometimes you get questions with respect to these definitions. If you're not aware, you lose 1 mark unnecessarily. Even though I say it, you might not think it's important. So I'm emphasizing that it is important. So don't take it for granted when I'm emphasizing it so much. Representative fraction is statement in words, the first form of expression of scale. Put into mathematical form and calculated from the equation, something that you already know. A very important statement that could confuse you in exams. What is chart length? Chart length will always be 1, no unit. If your chart length in your expression is not 1, then you'll have to bring it to 1 by dividing that particular value by itself. And when you divide a particular numerator by itself, you have, or by anything, you have to divide the denominator also. So remember, this is a thumb rule. Chart length is always 1. In your books, they have used these words that can confuse you by convention. It means by a rule, as a rule. When they use the word convention, it means as a rule. RF is dimensionless. Remember, okay? Before we go to the numericals, scale is further classified into 2 parts or 2 ways, okay? This is another aviation contradiction. Be careful over here. Large scale and small scale. Example of large scale is this. Example of small scale is this. I'm just underlining the zeros for us to be easily able to read because we have done frequency, so we know 1000, 1000, 1000 is how we bifurcate. Be very careful. Large scale, the denominator is small compared to the denominator of a small scale. This is the contradiction I was talking about. Use your scientific calci and give me the answer for 1 divided by 50,000. Give me the answer verbally. Whoever comes first gets a reserved treat in future. As in
2
something
into
small.
10 to the power minus 5.
Oh my God. 10 to the power what? Say again.
Minus
That's
5.
so quick. No, say again the whole answer.
2 into 10 to the power minus 5.
2 into 10 is to minus 5. So it means, how do you write it in decimals? Minus 5
It's
will be of decimal.
0.2 into 10 to the power minus 5.
So one person. Jyotsna, you tell me.
It's 0.00002.
Very good. Very good, Muskan. Very good, Jyotsna. 0.00002. Yes. So that minus 5 shows you these 5 zeros here. So now you see this number. Now someone please do this. Scientific calci. What do you get? You can just increase the number of zeros after decimal also here, based upon what you did in 50,000. One more thing, students generally in India would deal with numbers with respect to millions, but I want you all to know 1 million is 10 lakhs for us. 10 lakhs. It will mean 1 followed by 6 zeros. It's like 1 megahertz. Okay. Millions. So this is 5 million. Why 5 million? Because it's 50 lakhs if you see. A million will have 6 digits, 6 zeros. Remember that, 6 digits, million. 10 million, of course, will have 7 zeros because 1 is 10, 1 is with 10. So what do I get as my small scale? 0
0 0 0 0 0 0 2.
0
6 times 0 2.
Now, which is the larger number, students? The one on your left or the one on your right?
One on the left.
That's why it's called large scale. It's not called large scale because of the size of the denominator in the fraction. But when you solve it, what you get in decimals, comparing that, you get large scale or small scale. So such questions are frequently asked to check your confusion levels here. Will you be careful? What is large scale, small scale? Simple. Whenever I'm using large scale, I get two things. I get smaller denominator and high detail. In bracket, I can write accuracy. But don't use this word. This is just for our understanding. Go with detail. It has high detail, high accuracy, students, but a drawback is because we have scaled down to a smaller value, our chart is going to be big. So in order to have it in the size of the Jepson sheets, a high scale chart will only cover very less area. सुन रहे हो सब लोग? ध्यान है सबका? Or you want me to entertain you all a little bit? See, I don't know dance. So if I dance, everybody's gonna laugh. Don't ever believe I'm gonna dance for anyone, okay? I'm just saying that. So my large scale will give me high detail, that is accuracy, but it covers less area. So these are 3 important points about large scale. And about small scale, you will write, it has a bigger denominator or a larger denominator. It has less detail, but it covers lot of area. So the chart, the atlas that I was talking about, small scale, covers the whole earth. This is small scale, covers the whole earth, but no detail. Mumbai is not even, yeah, Mumbai is just one dot on this, no detail. A dot in Mumbai is actually a dot in Mumbai. Mumbai is not a dot. हर जगह यही होगा. I can see Chennai, Kochi, Mysuru, Bangalore, Tirupati, Vijayawada, Hubli, Hyderabad, Pune, Machilipatnam also. Wow. Talk about not having details. Mumbai, Puri, Raipur, Nagpur, Surat, Ahmedabad, Kolkata. So you see only major cities. No detail. This is small scale. Large scale, the globe had to be very big. Very, very big. So I could have seen more things. So you can imagine it like this. Yeah, many people make these videos. You must have, I'm sure you all must have seen. Zooming in into the earth from above. When we see earth and then the camera goes down, 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 and it pans out to one house finally. Similar things happen here. All right. Any questions? Go through your notes. See if you have any questions. After this, we'll take a short breather and start with our numericals. Quick. Chaitanya, Yukti, Muskan, Vishnupriya, talk to me.
Negative, sir. No doubt.
Sir.
I took 4 names. I'm waiting for everyone.
Yes, sir.
Talk to me, Chaitanya. Rohita, Yukti.
Yes, sir. The following is understanding.
Likit.
So following, sir.
Yukti, how about you? I think Yukti is not there in class. Yeah. I'll have to keep a watchman now on the door. Not allow students leave in between. टीचर मुड़े नहीं कि बच्चे क्लास से गायब हो रहे हैं. क्या हो रहा है? I've never done that. I'm just kidding. I know could be disconnection. Okay. Read everything. I hope you have written down things. I'm not sure how much you have self-studied or not, but as a general assumption, an hour and 15 minutes ago, we didn't know what is scale. An hour and 15 minutes later, we know so much. Not just scale, but projections. Oh my God. Plotting, planning, figuring out real distances using Jefferson charts, conversions. I mean, what would you call it? Best 70 minutes of investment. That is what quality education actually does. It takes time, but it has its advantages, brilliant advantages. Why do you think PhD students take 10 years to get a PhD? Do you think they're lazy? Just think about it. Trying to do everything in 3 to 6 months. Of course, it's possible, but will it give you everything that you need in your education against the investment of the money? No. That's the difference. That's what I am trying to give you. You have to believe though. चलो ठीक है. Good. No doubts. Good. We'll do one numerical and then take a break. Okay. I'll give you a few textbook examples only so that when you're revising or reading, it helps you figure out things better. Okay, write down the first one. What is the scale on a chart when 5 centimeter on chart length represent 7 nautical miles as Earth distance? This question, make it a base for all questions, because in questions they will not specify chart length or Earth distance. They will only tell you find the scale on a chart where 5 centimeter equals 7 nautical miles. That's it. You need to know the cm is chart length. You need to know the nm is Earth distance. All right. How do you do it? Scale RF is equal to chart length upon ED is equal to 5 centimeter upon 7 nautical miles. I wish it was this easy. It is not. Nothing is easy in life.
So we have to bring it in the same unit.
Yes. Very good. But that's not enough. So there are 2 thumb rules. One is chart length is always supposed to be 1. And second is the numerator, that is chart length, and the denominator, both should be in the same unit. Two steps. When you'll read the text, they will tell you the solution based on memory in conversion factors, but I don't want you to struggle there. I want you to just convert using your CX3. So CX3, conversion 1 by 1, and then doing scientific calculations to come up with the correct answer. Okay. So what do? Firstly, I can convert into the proper units. My strategy is if you are getting 1 centimeter, stick with centimeter only everywhere because the RF will be the same no matter what unit you take. You can convert the CM in nautical miles also, but then you will get the answers very decimal based. It becomes difficult. So it's always better to match the unit of the denominator with the numerator. So firstly, I hope you're doing it on CX3. You don't need me to show you on CX3. If anybody would want me to show you on CX3, tell me. I can very well do that on the screen right now. And don't lie, okay? I mean, generally you can, but not with studies. I'm actually like joining my hands, like request. Okay, so Yukti is back. So Yukti, this is the question. Quickly write it down. And this is the solution. Rule number 1. I'm writing rule, not step. Rule 1, or you can call it step also here. Match units as per CL unit. It means you'll have to convert. So 7 nautical miles in centimeter, how much? CX3.
129600 centimeter.
Say again.
1296400.
1296. Wait. 7 nautical miles to centimeters using CX3. What do I get?
1296400 centimeter.
Chaitanya, same answer, right?
Yes.
Something क्या? पूरा accurate चाहिए मुझे. Come on,
हाँ
Chaitanya.
सर सेम है सेम है.
नहीं, वापस से बोलो. I'm just kidding.
1296400.
400. Okay. Vishnupriya, confirm?
Yes, sir.
Okay. So now I get, therefore, my RF or scale is equal to phi upon 1296400. दोनों centimeter में आ गए. Both are in centimeter now. What is the second rule? The first thumb rule that we learned?
You have to do chart length 1.
Yes. Chart length always 1. Therefore, phi divided by phi. Therefore, chart length is equal to phi divided by phi is equal to 1. And whenever you divide a numerator by something, you have to divide the denominator also by the same thing. Note, when dividing numerator, that is chart length, by a number, the denominator, that is a distance, also needs to be divided by the same number. If you miss even a single step, you will be confused. Please study this carefully. Therefore, RF is equal to phi by phi upon 1296400 by phi. So I get 1 upon scientific calci. What is 1296400 divided by 5?
259,280.
Yeah. Yeah. Sorry.
259.
Say again. 1296400 divided by 5.
259,280.
259,280. 259,280. You got your answer. In the exams, Either you will get accurate answers like this, or you'll get rounded off answers close to this, something that you already know. Quickly study the steps.
Write the unit.
Sorry, Chaitanya. Yes, very good question. Say again.
Do we also write the unit like centimeter?
RF, no units. Dimensionless. Remember. Gone. All units are gone. Now you look on the chart. If centimeters are units, then one is also centimeter. The bottom is also centimeter. Both are centimeter in this case. But if one is centimeter, then provided, getting it? If one is 1 inch, then earth distance is also in inches. If one is 1 feet, then earth distance is also in feet now. If one is 1 nautical mile, then earth distance is also 1 nautical mile right now. Got it?
Yes, sir.
Pakka?
Yes, sir.
But RF mein, there is no unit. Of course, you'll have to determine the unit. That's the reverse calculation. That's what we are going to learn after the break. Not reverse, but actual calculations that you will need to do when you are plotting. What is the earth distance? When this is the scale and this is the chart length. The first type of question. Then, of course, they'll give you all sorts of mix and up. Practical, non-practical, both. To check your logic. Think. Questions. Go through everything. Go through this numerical. Stick to this technique. You will always need the answers in fraction, students. No decimals. You cannot divide this. Your RF will be in fraction, 1 upon something. It will not be in the ratio. If all options are in ratio, then just find RF and then do the division. Possibility somebody might give you that kind of question, but generally no, RF will not be represented like that. They might ask you a ratio, but you might have to find RF first and then put the ratio, but not even ratio. You might get the 0.00 something, probably, but no, RF will always be a fraction. Remember that. Representative fraction, which is dimensionless. Right, students? You're getting it? Am I the only person who's having fun? मेरी शक्ल से इतना लग नहीं रहा है, but still. Okay. Yukti, you got it? Chaitanya, continue if you have the doubt. Keep discussing.
नहीं सर.
नहीं करना.
मतलब नहीं है. Negative.
Okay. Quickly. Okay. Let's take a break. And then we'll solve. Short break. Just freshen up. Kitna chair, students? How much? 15 minutes? 20 minutes? Sorry, Bishop, I didn't hear that clearly.
15 minutes.
Okay. Anybody? 20? No? 15-1, 15-2, 15-3. Sold. Okay. Chal. I'll meet you at 3:45, everyone. Welcome back, everyone. I think I'm waiting for a couple more students. Take your time, settle down. Now is the easy part. Just calculations. Easy. Now the calculator will do all the thinking. You just have to feed the data. But again, I wish everything was that easy. Chaitanya Yukti, where are you? There are some jobs where a 15-minute break, you can do so much in 15-minute break. So much. You end up getting a minute or two spare. And abhi to 15 minutes went like 5 seconds. I think it's just me. I don't know. I'm just feeling like that. Maybe because I got bored waiting. So Prerit is back. Nakul, Jyotsna, Sridhar, Rohita, are you also there? Nakul, आपका मैंने बंद किया था वीडियो, अब चालू कर सकते हो आपको करना है तो. Yeah. करिश्मा, मुस्कान, गुलशन, लिखित,
Affirm, sir.
विष्णुप्रिया, चैतन्य.
Affirm, sir.
Yes, sir.
Very good. I'll give 1 minute or two. Otherwise, I'll give you all the question. It's very simple. In the textbooks, the procedure is also there mentioned, similar procedures, but you stick to what we are learning here. Okay. Over and above that, everything else basically will be the same, but don't get confused because it'll be very confusing there to understand. So make sure you know what to follow and what to avoid when you're going through the text. Okay, I'll write on the question. A scale of 1 is to 5 million. Right on. With a scale of 1 is to 5 million on a chart. With a scale of 1 is to 5 million on a chart. How many, or write down like this. Find the earth distance in nautical miles for a chart length of 1.7 centimeters. So for that example, when I was plotting it, I got 10 centimeters and 1 centimeter was what, 10 nautical miles for me. I got 100. I got 10 centimeter chart length for my 100 nautical miles distance. Here they are asking you, for this scale, 1.7 centimeter on chart will give me how much? So this is what we will be actually doing during our plotting and flight planning phases. So I'll show you the steps. They're very easy. Focus. Just focus how I'm showing it to you. Just see once and then you do it. Okay. Solution. Simple. We know one formula. RF is equal to CL upon ED. What is our RF? Our RF is equal to 1 is to how much? 5 million, is it? So this is my RF. My chart length right now that I have, okay, is 1.7 centimeter. In these kind of conversions, your job becomes much more easier compared to the first one. I'll show you how. Earth distance you have to find out in nautical miles. Okay. So let's put the formula. RF will write like this. 1:5000 is equal to 1.7 centimeter upon Earth distance. Has everybody got this? If you don't know how to get this, you will not get the answers. Simple. RF as fraction. Jyotsna, in your case, when you were getting fractions, you were getting answers in decimal. You can easily convert it into fraction by pressing the key X, this key. Sometimes when we choose certain numbers first and then the other, then you will get the answers the way you were getting it. In order to turn into fraction, you just have to press this on the scientific calculation. Okay, remember this. So now you'll cross multiply. Very easy, okay? I have the scientific CX3 shared so that I can show you conversions, but I'll do the calculation here, this calculation here. But first I'll write it clearly. So now see, what happens when we do cross multiplication? You need to find ED. Okay. So you need to go on top. The equal to sign is one such sign that if you want to shift something from here to there, you change its orientation to the next. If this is the denominator, it will become numerator. And what is the numerator will become denominator. So let's take this here and let's take this here. So we get ED is equal to 1.7 centimeter into 5 million divided by 1. And this will also come down. ये numerator है तो denominator बन जाएगा. If it's a numerator, it will become denominator. Okay. Then on your scientific calci, do this. 1.7 into 5 million. And be careful, it's 1.7 into 5 million. Simple. It's very simple. Here you don't need to do anything till now. Just do this. What do you get? You get 850,000. This is centimeter, students. Because the first unit you had was centimeter. Now put this in the unit conversion. Now eyes on the CX3. Here there's nautical miles. I will change it. Yes, yes. I'll change it to... Sorry? Yeah, 50. Yes, thank you. These kind of silly mistakes can happen because I didn't take 5 million. I took 5 lakhs. 1.7 into 5 million. Yes, thank you. Delete is equal to, yeah, 85,000,000 centimeters. Now focus on the CX3, the distance, the green check mark that is there, that part I've highlighted. M is for meters. In the fourth column, the third button, convert unit. It's grayed out, I guess. You click on it again to get centimeter. Keep clicking it till the time you get centimeter. You'll get all units. You got centimeter. Now put this value. 858. Press C and 85,000,000. Enter it. And then you can change the unit converter. And whatever you get in nautical miles is your answer. A very simple thing, but it's not simply explained in the textbooks. It took a while to make it this simple. But it's easy. Some of you all have got it, I'm sure. So your Earth distance right now for that scale is perfect. Individually, whatever is applicable to you, work on it right now. Quickly discuss if you have questions. Otherwise, I'm in doubts. Otherwise, I'll give you practice questions now. Jyotsna, good job. Very impressed. Chaitanya, Rohita,
Yes, sir.
what's happening?
Got the answer, sir.
Very good. Easy. Remember the steps, okay? Simple steps. Many ways to do it, but this is simple. Sure. Any doubts, anyone? Vishnupriya, anyone? Karishma, all okay?
Connected. Yes, sir.
प्रेरित सब आ रहा है समझ?
Yes, sir.
वेरी गुड, वेरी गुड. श्रीधर, क्या हाल है?
Yes, sir. समझ रहा है सब कुछ.
And students learning offline? So many students are not attending live. I hope everyone is getting it. All right. Chalo. Let's start. I'll give you some easy questions, some tough questions. Let's see if you can figure it out. I want to make it a little difficult. So I'm thinking of not giving you options at first. Let's see if you can come directly with the correct answer. Okay. If that doesn't happen, then I'll give you options to help you figure out what's the correct answer. Okay. On a chart, ED of 5 km is represented by 1 centimeter. Find RF. For first question, for few questions, I will not set any timer or something. Take your time. Like I told you, be careful. Don't rush. You might not get it in the first go. Don't have too much of expectations. Go with the flow and see what you're getting. Looks simple. I'm also doing it. So I already have 1 centimeter. I have 5 kilometers. I need to convert that into centimeter. So first I'll choose kilometers. I'll do C to 0. And then I'll put 5, enter, and convert into centimeter. So I get 1 by 5,0,0,0,0. So my answer is 1:. Students, I need answers like this. इससे ज़्यादा you don't have to solve. You don't have to solve beyond this fraction. Remember, it's a fraction. We need the answer in fraction or ratio. That's it. We don't need the answer in decimals. But be aware, it could be asked in decimals. Not a big deal. You just have to divide. But when RF is asked, you will only give me, what will you give me? Fractions. You can send me answers, WhatsApp, wherever. Everybody getting the same answer? Likit, good job. Send me on WhatsApp, students, your answers. Zoom रहने दो इसके लिए. Okay, प्रेरित. जिसका आ गया Zoom पे ठीक है. प्रेरित, fine. Very good. You can write it as 1 by or 1:2. Same meaning. Likit and Prerit, I've got yours on Zoom. I'm checking on are free to use portal. I mean, they're taking our data for sure, but yeah. Students, do you get my jokes? Krishma, correct. Are you very good? Very good. Vishnupriya. Chaitanya, very good. श्रीधर एक 0 कम लग रहा है. श्रीधर क्रॉस चेक.
सर आपने 1 0 कम लिखा है.
या गलती से लिख दिया. स्टूडेंट्स बी केयरफुल. फोकस. मेरा कॉपी पेस्ट करके मुझे भेज रहे हो? हाँ, सब पकड़ रहा हूं मैं. हाँ, एक एक करके सबको. यार सर ने लिखा वही भेज रहे हो तो क्या मतलब फिर? जस्ट किडिंग. बट यार श्रीधर, क्या मेरे कॉपी करके मुझे भेज रहे हो? मैं तो गलत लिख दिया था. मेरे को फ्रैक्शन चाहिए श्रीधर. करेक्ट फ्रैक्शन दो आंसर. ये जो आंसर तुम्हारा है वो पूरा फ्रैक्शन नहीं है. जो आपने पेन पे लिखा है ना, वो क्या है मेरे को नहीं पता. ये फ्रैक्शन तो नहीं है वो. आंसर को वैसे नहीं लिख सकते. ऑल्दो द नंबर इज करेक्ट, आंसर को वैसे नहीं लिख सकते. एनीबडी एल्स? एनी डाउट्स? किसका रह गया है? हु इज लेफ्ट? जितना गुड. प्रेरित गुड. So 1 2 3 4 5 6 7 8 9 10. 3 लोग का रह गया है. 3 people are left. Not getting it, students? So Sridhar, Rohita, Chaitanya, Vishnupriya, fine. Prerit, fine. Muskan, Karishma, fine. Likit is fine. So Gulshan, I think तुम्हारा रह गया है. What's happening, Gulshan? Are you not there? Nukul, I think you've done on Zoom chat, is it? No, Likit,
Sir,
yeah, I got
send
your
you.
answer. Got your answer, Likit. Got it, got it. Nukul, yours, I didn't get it.
Sir, I have sent you.
Zoom पे नहीं आया, WhatsApp कर दो. All right. Well, good job. Okay. Easy. Chalo. Let's get done with it. Find RF when 5 inches represent 8 nautical miles. Now you know inches would be chart length, 8 nautical miles is the distance. Now you know. So you narrow it down, word simple. The numericals will be like this for you. So don't be confused. सब WhatsApp पे भेज दो मुझे आंसर. ठीक है?
Sir, what is the unit of 5?
Inches. Iron. Iron here stands for inches.
Okay.
Yeah. Good. Students, confirm if you have any doubt. 5 inches represent 8 nautical miles. Find RF. There is one shortcut also here. I can show you. I won't call it a shortcut, but it's one way it's mentioned in class. First, you convert 8 nautical miles to inches, whatever unit you have for chart length. And once it's converted into inches, just divide by the chart length. Simple. It's exactly the same. 5 divided by 5, and you anyway have to divide it by 5 only. So you don't have to do that 5 by 5 to get 1. You can put directly 1, and then whatever 8 nautical miles you have converted to inches, that you divide by 5. So I'll just solve, cross-check your answers, but look at the way I'm solving, okay? So what I'm going to do, first I'm going to convert 8 nautical miles into inches. Now let's see in the exam how we're going to solve fast, okay? So I'll quickly first choose nautical miles. Okay, nautical miles. I'll press C to bring it back. Then I'll put 8, enter. I go step by step always. Then I put unit converter to get it into inch. So I'm getting answer in 58307 inches. This I divide by the numerator itself. Is equal to 11666. That is 1 divided by 11666, right? 1 something is wrong.
So
Five,
6, 6,
eight.
1. So 8 nautical miles is the chart length and 5 inches is the arc distance.
1 second now. 5, 8.
That is 111661.
Wait,
Yes, sir.
wait, 5, 8 nautical miles. 583,307, right? That I have to divide by 5. Correct. I was just not reading it well. It is 1. 116,661.4. So that 1 is, see, this, all these human factor things will happen when you are exhausted in the exam. See, I'm showing you live. It can happen with anyone. You don't need to worry. You need to be careful. It's not a point of being embarrassed or something. For you, what matters is getting to safety by getting things correctly. And you have time. Be very careful. So I can sense always something is missing. I try to find it and I figure it out. That's what I want you all to do it because that's the way to do things. It's not because I do it. It's because that is the way to do it. So 1 is to 116,661. Correct. When you'll be matching answers with your textbook master key, you'll have slight differences because they'll be using analog, which will be more accurate or less accurate compared to CX3. It'll be close. Or it could be rounded off also, whatever is closest. So you match always the closest answer. Is everybody getting this?
Affirm, sir.
Affirm,
Anyone
sir.
who's not getting this? Chaitanya, are you getting this?
Yes, sir.
Good. Easy? Chalo. Do one more like this. Same. Find RF. When kilometers is represented by 3.5 inches. Sure. kilometers, 3.5 inches. Kilometers, 3.5 inches. So I get 27559006. 27559006. Divide by the numerator, which is 3.5, and I get 1 is to 787,401. In your books, this will be rounded off as 78, and the last, this digit here, this is rounded off to 8,000. Like this. So see how they are rounding off 6-digit numbers. Generally, we round off just 1, 2, 3-digit numbers, right? See how they are rounding off 6-digit numbers. It will help you choose the correct option. Otherwise, in rush, you might miss out in the exams. So be very careful how they are rounding off 6-digit numbers. Someone could have said, sir, I should take it as 7,000. Why 8,000? Because it's less than 7,500. So maybe that's not applicable. Or maybe in your options, this would be the closest one, like that. So be very careful. Anyone who's not getting this? Done, everyone? Matching answers?
Yes, sir.
Affirm, sir.
Chaitanya?
Yes, sir, doing.
Doing it, okay. Let me know once done. And students, feel free to tell me if you're confused, if you're doubtful, if you've still not got it. Feel free. Okay? Let me know when everyone is done. Quick. I want to give you a couple of more complicated questions. चलो चलो इतना टाइम नहीं लगना चाहिए 90 seconds, right? हो गया 90 seconds. 90 seconds are done. Who's left?
Done, sir.
Chaitanya, are you getting it?
Yes, sir. Done.
कोई confusion है?
No, sir.
जितना भी टाइम आपको लगा, क्यों लगा उतना टाइम, just talk to me. I'm not saying it's a problem. I'm just asking. I'm okay with it. Good speed.
The
Just
phone
ask.
off था. Phone off हो गया था.
Oh, technical issue.
Sir, I'm
बता
not
दिया
good
करो.
at that.
बता दिया करो. है ना? क्या नहीं मिल रहा नुकुल?
Sir, final answer नहीं मिल रहा मुझे.
क्या आ रहा है तुम्हारा फाइनल आंसर?
Sir is 7/5511,812.
7 अपॉन क्यों कर रहे हो? क्या चल रहा है? पहला क्या किया आपने? Did you convert kilometers to inches or did you do it kilometer to centimeter?
No, sir, inches.
क्या मिल रहा है?
2755
ये क्या है आपका? ये डिनोमिनेटर है ना आपका?
Right, sir.
तो डिनोमिनेटर को न्यूमरेटर से डिवाइड करो. क्या है न्यूमरेटर? तुमने क्या लिया न्यूमरेटर?
So 3.5 inches.
तो साइंटिफिक कैल्सी में 2755906 डिवाइड बाय 3.5 करो. क्या आ रहा है?
No, sir, it's 2755,906.
सॉरी, या वही 2755906 डिवाइड बाय 3.5. क्या आ रहा है साइंटिफिक कैल्सी में? साइंटिफिक कैल्सी में क्या फीड कर रहे हो? बताओ ना, टॉक टू मी.
Sir, 3.5 upon 2755906.
वो नहीं डालना है आपको. वो कोई इक्वेशन ही नहीं है. हम क्या कर रहे हैं यहाँ पे? हम डिनोमिनेटर को न्यूमरेटर से डिवाइड कर रहे हैं. आप न्यूमरेटर को डिनोमिनेटर से क्यों कर रहे हो? क्या बोल रहा हूँ मैं? तुम उल्टा क्यों कर रहे हो? देखो क्या चल रहा है यहाँ पे. 3.5 अपॉन ये आ रहा है ना तुम्हारा 2755906. ये आ रहा है ना. हमारा सेकंड रूल क्या था? न्यूमरेटर हमेशा 1
Numerator.
होना चाहिए चार्ट लेंथ 1 होना चाहिए।
Right, sir.
तो 1 लाने के लिए हम इसको डिवाइड करते हैं 3.5 से,
2.5.
तो इसको भी डिवाइड करेंगे 3.5 से,
2.5.
तो क्या हो जाएगा 1 अपॉन, तो 1 तो मिल गया हमें, नीचे वाला वैल्यू ढूंढना है, तो नीचे वाला वैल्यू क्या मिलेगा आपको, कैसे मिलेगा, 2755906 डिवाइड बाई 3.5 से तो मिलेगा। तो आप क्या कर रहे हो, आप 3.5 डिवाइड बाई क्यों कर रहे हो, वो तो करना ही नहीं है, 3.5 को 3.5 से ही करना है, टू गेट द थंब रूल that the chart length will always be 1 as a convention. Nukul, talk to me. Where are you confused?
Yes, sir, 1 minute.
Where are you confused? Tell me. Did you understand these steps? इसी का डायरेक्ट स्टेप हम लोग करते हैं कि आप डायरेक्टली अर्थ डिस्टेंस जो भी मिल रहा है उसको न्यूमरेटर से डिवाइड कर दो। 1 तो हमेशा रहेगा ही आपके पास बाय डिफॉल्ट, तो आप शायद वो 1 भूल गए लेना। कहाँ कंफ्यूज हो, टॉक टू मी नुकुल, इतना टाइम नहीं लगना चाहिए। तो मुझे एंटमैन की याद दिला रहे हो, उसको इतना टाइम लगेगा एक एक बटन दबाने के लिए, कूद कूद के बेचारे को।
Okay, sir. Now I got the answer.
क्या गलत कर रहे थे?
सर वो मैं डायरेक्टली वैल्यूज पुट कर रहा था, तो नहीं आ रहा था आंसर।
याद रखो ये स्टेप, दोबारा से करो सॉल्व चलते चलते। एनीवन हु इज कंफ्यूज्ड प्लीज टेल मी। ये आंसर के लिए बनाया, नहीं तो फ्रैक्शन लगेगा सबको। लेकिन दीज हिंदी यू आर नॉट मिसिंग एनीथिंग। ओके, let's do the next one. And students who have textbooks, please don't copy, okay? For a half million chart, $30 kilometers is represented by chart length of dash centimeters and chart length of dash inches. So here the trick is to understand what is half million. We already know 1 million is 1 kilo, 10 lakhs. So half million would be half of it. You can easily divide that to get it. 1 million divided by 2. I get 5 lakhs, of course. So my ratio or RF is equal to 1 is to this. I have to derive if they only tell me half a million. They should give you ratios or fractions. They might not. They can say half million also. So you should be like, अरे सर मेरे को RF नहीं मिला, क्या करूँ, आपने सिखाया नहीं. I'll be like, you had to use your logic. अभी क्वार्टर मिलियन बोल दिया तो इसका हाफ हो जाए, 1 is to उसका हाफ. It will become its half. So this is my RF. So I'll do that 1 upon is equal to chart length upon earth distance, which is 30 kilometers. I'll do it in 2 parts. One for centimeter for cm and one I will do for, so I'll do it differently. For inches, 1 by 1. Chalo, do it once first for centimeter and then for inches. Give me your answers. Here, simple formula, cross multiplication. So it's very easy. You have to match, always remember, you have to match the unit of the numerator. So if you are assuming in centimeters, then 30 kilometers you convert into centimeters. Easy. And if you want inches, then 30 kilometers you convert in inches. Again, very easy. You get the answer. Okay, who's ready? Jyotsna, excellent. Perfect. Only 2 students have submitted. Rohita, cross-check your answer. Rohita, cross-check. Gulshan, very good. Gulshan, कभी भी decimal के बाद 2 point तक 2 answers. Rohita, wrong. Cross-check, careful, don't rush, take your time. See, it's pretty simple, students. Chart length ऊपर ही है आपका. The chart length is already above. Just take 30 kilometer above 50,000 and convert the 30 kilometer into inches if you want answer in inches, or centimeter if you want answer in centimeter. You get the answer. Rohita, it's 500,000. I don't know what you're taking, but kahin na kahin somewhere your error is in zeros that you're taking. 500,000, it's not 5 million. 500,000 is 55 lakh. I think I've taken one less zero. Sorry, students. Students, come on. Do the right thing. I'm missing out 1 zeros here. But you are smart. At least correct me there if you are making human error. 500,000 is 5 lakhs. Solve this. Sorry, who was saying something?
Sir, please check mine. So, Karishma.
Yeah, Krishma, 1 second. Sridhar, correct. Gulshan, correct. Karishma, correct. Krishma, पहले सेंटीमीटर का पूछा है तो पहले सेंटीमीटर का दो आप. 1 सेंटीमीटर, सेकंड 20 इंचेस. ऐसे भी ऑप्शंस आएंगे आपको. तो गलती से अगर एक ऐसा ऑप्शन है जहाँ पहले इंचेस दिया फिर सेंटीमीटर दिया, हमारा वो गलत हो जाएगा.
Okay, sir.
Yeah, but your answers are correct. I get it, but follow the sequence. First centimeter, then inches.
I've sent, can you
But
check?
correct. Yeah, I'm checking. But Chaitanya only half answer in centimeter. Correct, eh? Very good. I want answer in inches also.
Sending in inches, sir.
Yeah, very good. Perfect answer. Rohita, you got it. Very good. Vishnupriya, yes, you got it.
So scroll up for the question.
Yeah. For a 500,000 chart, 500,000 means 5 lakhs. 5 followed by 5 zeros. 30 kilometers is represented by dash cm chart length and dash cm inches. So for cm solve separately by converting 30 kilometers into centimeter, and for inches solve separately by converting kilometers in inches. So the correct answers are 6 centimeter and 2.36 inches. Very good. नुकुल सॉल्व करके देखो आंसर्स मैच हो रहे हैं क्या. Hmm. Any doubts? Revise. Students, revise. Quickly revise. We are about to wrap up. Revise if you have any questions. If you're going to master this, understand you're doing a very good thing. This is where people lose marks. Trust me, don't take it for granted. There are times when you get a lot of questions from these topics. Those are the bad times when you have not studied these topics. Any doubts, anyone? Go through everything that we have discussed, starting from drift to this scale projection. So much. Any doubts? Anybody facing difficulty? Nukul, did you get it? I'm sending you something right now. Mm. 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 So I'm sharing a folder with you all. This Prerit, Nukul, Jyotsna, Sridhar. Where is Sridhar? Please revise and tell me if there are any questions. This review is very important. Likhit, Chaitanya. Who else? I think Tejas, Hemant, Rishi. Okay. I've shared the folder. In the folder, there's one file, small PDF from Oxford. Highlighted points also, but read everything. Stick to what you've been taught. Anything extra, read, make a note. Small chapter, but very important chapter. Plus, solve the questions, cross-check your answers, send me your solutions once done, and if any dispute, discuss with me. Okay? Whenever you have time. Don't have to do it right now. You can do it right now also and send it. I am planning to meet you all tomorrow also at the same time. So stick to the same schedule. Okay? Unless otherwise, we are meeting tomorrow 11 a.m. Okay? In case you don't get a response at 11 a.m., you sit at your desk and wait for it. You don't move. All right? Simple. Okay? So you'll be like, okay, and sir will send me the link. I'll join Zoom. Otherwise, you keep studying where you are. Be ready in case that happens. All right? Any questions? Fine. I'm going to ask you questions, but not right now. Let's get done with projections. Let's get done with learning. But side by side, do self-study. Today and tomorrow, I'm not giving you any gap, but probably one day I'll give you gap if I have tasks to give you. Let's see. But make sure you find time for self-study. Do not rush. Focus on quality. Exams will happen. You focus on quality. Do not worry. If you focus on quality and you get everything right now, you might not even have to revise these topics that you're learning now if you have exams in March, because it will be very fresh. Right? If you're struggling with study schedules, if you have any other problems that are not letting you study, feel free to discuss with me. I can help you come up with strategies to manage time. Anything you need, just let me know over and above lectures. And students who have their exams in March, I think Chaitanya, I have already asked this to you. I'm saying this again. And anyone who plans that, sir, ek do mahine mein main bhi exam de raha hu, on demand de dungi, like that. Make sure you have a list. I have shared the syllabus with everyone. If you all don't have, I'll share the syllabus again. It gives you a good reference about what can you skip and what you cannot skip. Okay. Accordingly, make sure you have a list, general, instrument, radio, about topics you want me to do, or topics you have not done, or topics you are not thorough, along with topics that you are thorough with. That checklist is very important if you want to be 100% ready, basically. So Chaitanya, I have not got it, but send me if it's ready, whenever, so that I can focus more upon those topics. Right? Chalo, I'll take a leave. And yeah, make sure you talk, make sure you share your concerns, and remember, feel free. Okay? Feel free to let me know whatever you need. Okay? You don't have to be just focus on your learning. Be selfish right now. All right? And keep communicating, keep believing. That's it. If I want you to do something, I'll tell you, you do that. If you want me to do something, you can tell me, I'll tell you. Yes. Okay, fine. That should how it should be. ठीक है? Nukul, are you there? I think Yukti missed out on class for tomorrow. Okay, Nukul, Yukti, I'm not sure. Nukul, are you there? Checklist you have to make. I'm just sharing the syllabus with you all. Okay, for navigation. I'll put it on Drive and share the folder with you all only. Give me some time. All right. Will not do it instantly though. Chalo. I'm taking your leave now. I'll see you all tomorrow. Remember, 11 o'clock. You sit, request password and sit and study. That's it. 11 to 5 is the time. Take care, everyone, and I'll see you tomorrow. Thank you very much.
Thank you, sir.
Bye, sir.
Bye, sir.
Thank you, sir.
Thank you, sir.
Welcome.